Hey everyone, it looks like we are here. Okay, so yeah, today's kind of more chill. We're just gonna start right off with that. Today is definitely gonna be a little more chill. I don't know what I'm doing. Um, oh, hey, that's not how that show chat. All right, I'm trying to let the shaders compile on this project here so that we can go through it smoothly. At least that's the theory you know, theoretically it will do that. We'll see. But yeah, once that's done compiling, I will go ahead and get started with. So I haven't actually gone through any of these yet, so I'm starting fresh from the beginning. I think I'm gonna need. Oh, I have my soundy buds. Let's see here we go. Left to right. I don't think I want to put the whole headphones on. We will use the earbuds today. Oh, the surface is taking up so much space. Why? Y'all can hear that. Never mind, I know why. There we go. Actually, if I tab. Okay. What is that? That's weird. Okay. Well, the sound is gone. Okay. Hmm. We are close. We are close. It is almost there. Uh, what is NVIDIA broadcast? I don't remember. Can't I do this like on a per like a per game level sort of thing? Like I want it on, but I don't want it to record in. Oh, here, I'll just turn it off. Should make like a sticky note. Can I do new? Sticky notes. Uh, it won't open. Sticky notes doesn't work. Well, I guess we won't have sticky notes. That's unfortunate because now I will forget that I am not recording until I do something awesome and I go to hit my button and nothing happens. All right. Well, anyway, I think I'm going to go ahead and just shaders are done compiling. It is time I should be able to actually do the thing now. So, I'm gonna have this like playing on the side.
My name is Wes Bunn. I'm a senior technical writer at Epic Games, and in this series, we are going to be talking about what you need to know, the essentials, if you will,
This
to
voice
work
sounds
with
familiar.
a Blueprint visual scripting system inside Unreal Engine 4. We've got a lot to cover in this series, so I'll quickly outline what it is we'll be talking about in each video. First, what are blueprints? We'll talk more about the concepts and ideas behind them and what you can expect when using them. We'll then show you how to create blueprints and take a tour of the Blueprint Editor UI. We'll move on to components and how they are the bits and pieces that make up our blueprints. After that, we'll take a look at some of the different blueprint graphs that you'll be doing your scripting in. And we'll quickly touch on some of the different types of blueprints that you'll find inside of UE4, as Blueprint is used quite a bit throughout the engine. And finally, we'll talk about some of the caveats or things to consider when using blueprints. So with the outline out of the way, let's jump right in and start learning more about blueprint visual scripting in Unreal Engine 4.
Okay. Hang on a second. Sound settings. You know, there was a thing. Pair new output. Interesting. I thought didn't I have virtual audio cable? You know, that'd be cool if like virtual devices were like native in Windows. Like to me that seems like something that should be. Cuz really I'd like to just play some music for y'all. Wait, next? Is that download project file? Okay, yeah. I already did that. What is Blueprint? I don't know. What is a blueprint?
Blueprint visual scripting, or Blueprint for short, is a super powerful tool within UE4. But what exactly is Blueprint? Blueprint in its purest form is visual scripting, and contrary to popular belief, when you are working with Blueprint, you are programming. You're just doing so in a more visual way. So typically, people tend to fall into one of two categories. You either love programming or you don't. Programmers spend their days typing in lines of code
It's
in
fair.
something like Visual
He's
Studio.
not
Think
lying.
of it like this. And the code that they enter executes some form of functionality within their application. Blueprint lets you execute that same functionality, however you can construct that functionality without having to touch a single line of C++ code. You do so by connecting a series of nodes together, and those nodes have some functionality already attached to them. For example, here on the right, we have a node network that enables us to change the color of a light to green whenever our application begins. It's kind of like a flowchart if you've ever created one of those. However, with Blueprint, that flowchart actually executes your functionality. Now, Blueprint is the system that enables us to create content in this visual way. The actual content that we create, however, is oftentimes referred to as blueprints, or the tangible thing that you have created through blueprint visual scripting. So you may see the term blueprints. Just remember those are the things that we've created versus blueprint, which is the system itself. There are many different types of blueprint that you can create.
This is a long one.
We'll get into those a little bit later. But the best way to think about blueprints is that they act as a container for content. Okay, they can hold what we call components or
Whoops.
that make up our
Why can't I
blueprint.
just like...
For example, a car blueprint could contain the car's frame as a component, the wheels as a component, the engine as a component, etc. They can hold scripted functionality, but they don't have to. So
Hey, cool.
we could script some functionality that says when the gas pedal is pressed, tell the engine to move the car forward.
We'll do
If we
1.25.
script any functionality, it'd still be a car with an engine, frames, and wheels. It just wouldn't know how to move. Blueprints can also hold only data, and that data can be adjusted. So once again, in our car, imagine there's a car stereo. We can change the station, turn up the volume, put in a CD, whoever does that these days. But we don't actually change the functionality of how our radio handles turning up the volume or changing stations. We let the user perform the actions, and the functionality behind the scenes takes over. Data-only blueprints work in that same way. We give the user the ability to modify the blueprint, but not touch the underlying script directly. So let's take a look inside the editor at some of these examples. Inside the editor here, we're going to take a quick look at some example blueprints. The first one that we're going to look at is a blueprint door. It's just a simple door with some scripted functionality that allows us to enter this little box and open the door. So if we press play, so we approach the door opens. So leave, it closes. This blueprint has scripted functionality on how to open the door. It also
Whoa.
what we call components.
Hang on.
The actual blueprint.
Hang on.
Select the blueprint in the level here and go to edit blueprint to open it up. And you'll see that there's already some script in here.
Oh god.
Too concerned that what all
He's leaving me behind.
is see that there's one section for opening the door and one section.
Where's the levels? Where are the
the components on the upper left
base levels?
So we have the door frame,
Indoor?
the door, and we have a trigger which allows us to determine when the player actually enters an appropriate range for the door to open. So that's our first example blueprint.
What is this?
Right of that, we have a very similar looking
Oh, more shaders.
This door does not have any script. This door simply holds
Text.
components.
So I'll just say text.
So if we go and select it,
This can't be right.
inside the graph here, we have no script for defining how this door should open. So in fact, the door will not open if we approach it. All it has are the components that make up our door. So it has just the door frame and the actual door. Now, why would we want to do this? One particular use case, if we were making a vastly big apartment complex and it has thousands of
Fully finished example.
add a door frame and a door, or we could have a
Oh god.
set up for us, and we could just
What?
copy
What?
like so and place those wherever we want. And we could also set it up so that we could define what each door looks like through blueprint, etc., without actually having the functionality of scripting the door.
That is a pool.
Other examples here that we'll look at very quickly. We have a customizable light here. Similar concept.
Ugh.
We approach this little trigger volume, the light will come on. So we play. Volume, the light turns on. And
This is not.
exit, it turns on.
This is also not.
However, this particular blueprint, as we mentioned with the door example, how we could have parameters exposed that we could modify the way the door looks, which we can do through the details panel here.
Well, that's
change the light to
light rendering. Apparently I clicked on the wrong thing.
turn it on by default if we wanted to.
Content.
Play. Now the light's red. Again, this could be a use case where we have several different lights in our level.
What?
Customizable, but we don't want to provide artists with the ability to define how lights turn
Okay,
on.
hold on. Fundamentals.
That allow artists to tune and tweak with the way lights look, but keep that scripted functionality inside the blueprint in what we call a data blueprint. A data
Blueprint.
very similar to the blueprint that we just had there, except if we open this one up, we still have those properties.
Wait.
We open it up. We actually don't have.
What the hell?
Just giving us the ability to define the data for this blueprint. Inside the actual blueprint is the scripted functionality to determine how this light actually turns on. So it works just the same. We can approach it and it turns on. And we can change what the color of the light looks like, or the brightness, or the radius, etc. Other things to know about Blueprint is that Blueprint is a compiled object-oriented visual scripting language, meaning you'll need to compile your blueprints before running them.
Okay, found it.
In most cases, we're talking fractions of a second to compile.
It's already gone. It's already beyond
Also, if you're unfamiliar with the term object-oriented,
somewhere else already.
there are objects that contain data already, and that data can be accessed, modified, or called upon from within or from another object. In much simpler terms, you can create class structures where you start with a generic class, like a vehicle class, where all vehicles know how to drive, they have gas and brake pedals and steering wheels, for example. But from that vehicle class, all the functionality from the vehicle class you can take with you into a new class called trucks, for example. A truck knows how to drive, a truck has a steering wheel, a truck has gas and brake pedals, but you can add truck-specific stuff to it, whatever that may be. Maybe it handles a little bit better off-road, for example, or has bigger tires. you wouldn't need to redo all the base vehicle stuff, and all that functionality can be applied to other types of vehicles that you'd like to create as well, such as motorcycles, cars, or maybe even golf carts. The blueprint system ties directly into the existing framework classes within UE4 as well. So there's already a bunch of C++ code created for you, wrapped up in predefined classes that you can access. This means that you don't have to start from scratch. Some of that work has already been done for you. So here we are inside the editor, and I wanted to take a moment to look at some existing classes as well as the class hierarchy inside of UE4.
Okay.
So whenever we create a new blueprint, we go up to blueprint class, create a new blueprint, we're going to have the ability to pick a parent class. And this is where we can inherit some existing functionality from the class that we select. Most of the time, you're going to be working with actor classes here. These are objects that can be placed or spawned inside the world, as the tooltip suggests here. And you can look at the other tooltips as well to get an idea of what they are. But most of the time, whenever you're placing blueprints inside of your level, they're going to be based off the actor class. But I did want to expand all classes here to kind of show you the hierarchy and class structure that we have in place. So inside of UE4, everything derives from the object class. This is the base building.
Man, we are at like super base level stuff here, guys.
There's an actor, as we mentioned. There's the actor class. We expand that directly under actor. These are all the other things that are actors that we could place. So we have all kinds of different blueprints that we've already created, sounds, etc. But I wanted to scroll down and take a look at, let's look at pawn. So a pawn is the base class for all actors that can be possessed by players or AI. So this is the thing that you are controlling while your application is running. Also says it up here as well. It's the second one down from the list. If we expand pawn, now we have the ability to assign a character. So a character is the representation of the actual, as the name suggests, character that you're controlling inside of your levels. Now, you may or may not be controlling a character. You could be controlling a wheeled vehicle, for example. You could be spectating, which you have no physical body, but you still need to control something that you can fly around inside.
Which one is it? Is it
you could use a default
this
pawn,
one? Oh, hey, that doesn't work on here anymore.
It's just a invisible thing that you can fly around inside the level. But that's kind of what I wanted to identify here, is that you can have children of classes and inherit functionality from the class above it. So we have our pawn class, which we have the character class, which is a character that you can actually control. And then under that, you would have all the different types of characters that you have. So if you have a fighting game with a whole bunch of different characters in it, they could all be based off of the character class. And
I guess I got
functionality built in within them.
disabled.
Also completely embedded within UE4, so there's no IDE to interface with. We're going to take a look at this a little bit later in the series, but you'll find all over the engine that Blueprint is embedded in everything from animation to UI to materials, and sound editing are all node-based as well. It's predominantly used throughout the engine. And at its core, blueprints work by stringing various nodes that have some functionality together and making connections, where after compiling, you'll see the results instantly. So it has a very fast iteration time. You can quickly make changes and see those changes reflected instantly. When it comes to the different types of blueprints that you'll be working with, you'll mostly be doing your blueprint work inside of the level blueprint or class blueprints. Level blueprints are a unique type of blueprint that exists per level. So if you have things in your level that you want to provide scripted functionality to, you can do that inside the level blueprint. The caveat to that, however, is any scripted functionality that you do in the level blueprint will be bound to the level that you do it in. So if you change levels, you'll have a new level blueprint that you would need to redo that script in. Or you could use class blueprints, which are more modular in that the script that you create is bound to the actual blueprint you do it in. For example, the door here, that was a class blueprint.
I missed. Did we actually do anything?
So that we can place that blueprint in any level and it would just work.
Oh, we're gonna have a quiz.
The door inside the level blueprint. In each new level, we would have to do that. So it's much more beneficial if you're doing things in a module.
Oh, hey, you can actually like see the video.
Is that C++ is blueprint and blueprint is C++. And what I mean by that is blueprint is built on C++.
They should get rid of these borders.
So what that means is you can open up and edit blueprints in C++ if you desire. We also have a tool that will actually convert your blueprint.
Also, I hate that this is white.
Code as well, if you'd like to do that. The other thing that is great is that blueprints and C++ work well together. So you can create C++ classes with some functionality and expose certain parameters to blueprints so that your non-programmer types can access it and modify the
These are all things I knew.
Having to touch any code, they can do it directly inside of Blueprint. So now that we've taken a look at some blueprints inside of UE4 and discussed what Blueprint is, you should have a better understanding of how it can be used to script functionality in your own applications.
Ready, set, learn. You got it. All right. Next. Pass mark. All right. Let's. Oh, God. I can't read. This text is like invisible. What? What is this shit? Let's see. You need to reuse a blueprint multiple times to change minor parts of its functionality. What could you do instead of remaking the blueprint each time? Oh, wait. Oh, okay, hold on. There's a comma. This is a scenario. So, say you need to reuse a blueprint multiple times, but you need to change minor parts of its functionality. What could you do instead of remaking it? Well, let's see here. Guess you could duplicate it. Wait, create. We'll go with that. That's incorrect. Okay. Wait. I'm confused. Isn't that what I said? I can't even see this. Oh my god, why is it? Well, we did it. Wait, that was one question. What even is this? Creating blueprints and editor UI? Tell me the ways.
We're going to show you the ways that you can create blueprints.
He said it. He said it.
There are quite a few different ways that you can go about doing
We're gonna show you the ways.
We'll also take a tour of the blueprint editor UI so that we have a better understanding of what each area is and what it is used for. Now that we're inside the editor, let's go ahead and create our first blueprint. Now, there's a couple different ways that we can do this. Probably the most common way is through the content browser here. We're going to go to the Add New button. This is going to
add new.
all kinds of different assets,
I'm gonna
including the blueprint asset, so the blueprint class. If we select this, we're going to get the ability to pick a parent class that we want to base our new blueprint off of. Parent classes, again, is a bit of a refresher, allow us to inherit some functionality from whatever class it is that we select. Now, most of the time, you're going to be using actor classes.
Unzoom. Sorry,
There's all kinds of different classes that you can choose from.
Turn that off,
You
though.
can expand all classes, and you can get a sense of how many different types of classes there are, as well as the different actor classes that you can base your blueprint off of as well. So for this particular example, all we're going to do is select actor. So once we select actor, it's going to create an asset in the content browser, which allows us to rename the blueprint to whatever we want. So we'll call this test blueprint. Like so, test BP. Let's go ahead and open this blueprint up and take a look at the blueprint editor UI. So once we double click and open that up, we are now inside of the select.
Sorry, I didn't hear. What did you say?
Select actor. It's going to create an asset in the content browser, which allows us
Actor.
to rename the blueprint to whatever we want. So we'll call this test blueprint. Like so, test BP. Let's go ahead and open this blueprint up and take a look at the blueprint editor UI. So once we double click and open that up, we are now inside of the blueprint editor. And we'll come back to the types of ways that you can create blueprints in a moment. Let's take a quick tour of the blueprint editor UI. Now don't get alarmed, there's all kinds of buttons and options and things in here. We're going to step through this here together and talk about each of the different panels and what they do. First and foremost, we'll start in the upper left. We have
Like super quiet, isn't it?
Panel, and this allows us to
It's quiet as hell to me too. It's fine.
These are the bits and pieces that make up our blueprint. So we can add audio, we can add particle effects, we can add skeletal or static meshes, we can add cameras, all kinds of different components that we can add. And each of those components have some built-in functionality already that we can tap into. Directly to the right of that, we have the main toolbar here across the top, which gives us the ability to compile our blueprints. Whenever we're working inside of our blueprints, before we go and test them in the editor, we want to compile and make sure that there's no errors before we try to test something out. We can also save our blueprint from here, browse to it, and find it inside of the content browser by clicking this button. The Find button here allows us to find any references that this blueprint is being used by. We also have class settings, which gives us the ability to define class-specific settings for this particular blueprint, as well as class default. Now, these are the default properties for this particular blueprint. And we'll get into this a little bit more when we start talking about variables down the road, how you can set up your variables and access them from the class defaults option. Directly to the right of that, we have simulation and play, so we can simulate our blueprint or play and see our blueprint running directly from these two options here. This little drop down here allows us to debug different instances of our blueprint. So if we have multiple light blueprints in our level and we want to debug one of them, we can click this drop down. They will all get populated here, and we can choose which one we want to debug at any given time.
Neato.
Right of that, we have the details panel. This is where all the properties are that we can define and make adjustments to. It is context sensitive, so if we have different things selected, different properties will be displayed here. For example, if we added some components, so if we added a static mesh, which we can search for from the search window up here, we can select that static mesh, and now we can define properties for that static mesh, such as the location, rotation, and scale. We can actually define what the static mesh is, so we could say cube, for example, something like this. So here we have a cube inside our blueprint. We could add additional components such as lights, for example. So we can add a point light, and that light, we can move it up. We can come in and change the light color, etc. So these are all the properties that you can define inside of the details panel. Kind of been working in it already, but to the left of that, we have our viewport. This is where you can come and see all of those components that you've added. So for example, if you had something like a car, so you'd have all kinds of different meshes for the car, you could see that and put that together inside of the viewport panel here. The viewport panel is broken up. This intersection is broken up into 3 tabs, I should say. The viewport is the default tab, but we also have the construction script. And
I've never used construction script, I think, on blueprints.
Parameters or prefabs of this blueprint. This is very useful if you have level artists that are setting up your levels and you have blueprints inside of your level that you don't necessarily want to enable them to modify the script, but you want them to change the value of some things. You could set up a script inside of here that exposes those values. So say, for example, the light color, we could drag this in here and say, allow the user to change the light color or intensity. And that will update inside of the editor so they can see that reflected as they're putting together their level, essentially. This fires whenever any modifications are made to this blueprint. It also fires at runtime when the game begins. Directly to the right of that, the third and final tab is the event graph. This graph is used for updating blueprint script at runtime. So while the application's actually running, this is where you're going to be doing most of your scripting, is probably in here, as this is the moment-to-moment script that is being run. Over to the left, we have the My Blueprint panel. This is where you can see all your different graphs that you have, any functions that you create. You can actually create them here or override functions or see the functions that you have created. We also have the ability to create macros, which are kind of like a utility tool.
I don't often create graphs.
Streamline the way that your
I'm not really sure the reason why you would. I guess organization.
Things that are going to change, they vary from time to time.
I think I saw somebody did a graph just for input.
Effectively a communication tool that you can use to communicate between different blueprints. So that, in a nutshell, is the blueprint.
Like on a character blueprint.
I'm going to close this out for a second. We've created our blueprint here. You can actually see that the thumbnail has updated, and we now have a test blueprint. To bring it into our level, we could just drag it and drop it directly inside of our level. Now you can see that we have our cube and a light here, which is pretty cool. This is referencing the asset that is inside the content browser. So this isn't a one-to-one relationship.
Look at it.
If I were to make another
so
copy
majestic.
Of that, this is a separate instance of this blueprint. So we can make modifications to this blueprint without it affecting this one, unless we set the script up that way that we want them to affect one another. So for example, on this particular one, I can come in and change the light to red, and you can see it's not affecting the main blueprint. Our main blueprint is still using that white light.
Oh, it's
Let's
salt.
take a look at this other stand here that's completely empty. We created a blueprint from the content browser by clicking the Add New button and going to Blueprint Class. You can also right-click inside of the content browser and go to Blueprint Class as well. It's the same menu, and it'll pop up the Pick Parent Class option as well. If you go to the context menu, either from the Add New or by right-clicking, there's also, under the Create Advanced Asset section, under Blueprints, there's some additional assets that you can create in addition to the Blueprint class, which you can create from here as well. You can also create a function library, which is just a collection of functions that you can access from other blueprints. Blueprint interface is another communication device that you can use to communicate between different blueprints. The macro library, similar to a function library, is just a collection of macros that you can use in different blueprints. Enumeration is just a named list that you can create that you can use inside of your blueprints for flow control. So, for example, you could have states of a character as a enumeration, and the state of your character could be that the character is alive or dead or hurt, and you can have those as an enumeration, and then based on those different states you can switch and do different things inside of your blueprints. Structure is a collection of different variable types. So for example, if you had a character that had an inventory, for example, you could have a pickup item structure, and that structure could contain things like the name of the pickup, a thumbnail to appear inside of the UI, a static mesh to represent it inside of the world, maybe a sound effect that it plays when you pick it up, etc. All those could be contained within a structure, and they are all of different variable types. Let's take a quick look at how we can create blueprints in a slightly different approach. So before, we created in the content browser, we created the asset. Inside the asset, we added our components that make up our blueprint. Another thing you could do is you could work inside of the editor. So we could take something like a cube here, and we could take a light, for example, and we could put that on. We could just move it up, something like this. And maybe we wanted to have a trigger box, for example, that when the player enters this thing starts spinning or the light changes color. Whatever components that we want to make, we could just keep adding them to the level here. And then once we're happy, what we could do is we could select each of them by holding Control. Now that we have them all selected, I think we do. Let's double check and make sure that we do. Probably could move that out a little bit, make it easier to select. Or select it first. Then we can select that and our light. Now we have all three of those selected. What we could do is we can go up to the Blueprints button at the very top here. Second option down, aside from creating a new blueprint class, is to convert those selected components to a variable types. Let's take a quick look at how we can create blueprints in a slightly different approach. So before, we created in the content browser, we created the asset. Inside the asset, we added our components that make up our blueprint. Another thing you could do is you could work inside of the editor. So we could take something like a cube here, and we could take a light, for example, and we could put that on. We could just move it up, something like this. And maybe we wanted to have a trigger box, for example, that when the player enters this thing starts spinning or the light changes color. Whatever components that we want to make, we could just keep adding them to the level here. And then once we're happy, what we could do is we could select each of them by holding Control. Now that we have them all selected, I think we do. Let's double check and make sure that we do. Probably could move that out a little bit, make it easier to select. Or select it first. Then we can select that and our light. Now we have all three of those selected. What we could do is we can go up to the Blueprints button at the very top here. Second option down, aside from creating a new blueprint class, is to convert those selected components to a blueprint class. So when I select this, it's going to ask us to select the path where we want to save it. And I'll just go ahead and save it under the Blueprints folder here, under this, and point it to Finished Assets and Blueprint down. Aside from creating a new blueprint class, is to convert those selected components to a blueprint class. So when I select this, it's going to ask us to select the path where we want to save it. And I'll just go ahead and save it under the Blueprints folder here, under this, and point it to Finished Assets and Blueprints. And we'll just say that this is component.
So I have because I'm on 5, I have a different UI.
When we create it, it opens up the blueprint editor for us, and you can see that it's added those components for us automatically. So it's the same manner as going through and adding them from the components window, but it just gives you a slightly different approach if you want to build everything out first. But it's
you just do like a
components for us automatically.
actor.
So blueprints, convert those selected components to a blueprint class. So when I select this, it's going to ask us to select the path where we want to save it. And I'll just go ahead and save it under the Blueprints folder here, under this, and point it to Finished Assets and Blueprints. And we'll just say that this is component-based BP. When we create it, it opens up the blueprint editor for us, and you can see that it's added those components for us automatically. So it's the same manner as going through and adding them from the components window, but it just gives you a slightly different approach if you want to build everything out first, and then once you're happy with it, then go ahead and convert it to a blueprint. Now that you know the different ways that you can create blueprints in Unreal Engine 4, I'd recommend that you go with the method that is most comfortable for you. We also took a tour of the blueprint editor.
Definitely in the first one.
Each of the different panels and what they are used for. With that, if you're ready to, move on to the next video in this series to learn more about working with components in blueprints.
Yeah. Oh, these are long. Dang, man.
Components are the bits and pieces that make up our blueprints and can also have functionality or properties attached to them that we can access. In this video, we're going to take a look at where and how we can add components to our blueprints, accessing their properties, and touch on some of the different types of components that are available. Let's go ahead and start working with components inside of a blueprint. So I'm going to create a blueprint by right-clicking in the content browser here and just going to blueprint class. And we're going to be using an actor so that we can place it in our level. And I'll just give this a name, static mesh underscore BP. I'm going to double click and open this up. And once we do, we are inside the blueprint editor now on the Viewport tab, and we have the ability to start adding components, which we can do from the components panel in the upper left here. So if we click the button for add component, we're going to get a list of all the different types of components that we can access. Now each of these components have their own properties and functions and data that we can tap into. For example, we have audio, which can be used to play a sound. We have particle effects. We have lights, skeletal meshes and static meshes. We have AI. If you want to give your character AI behaviors, you could use some of these components. They all have built-in functionality. We have different shapes. You could use a camera as like a third-person perspective. You can also use cinematic cameras if you have cinematic that you're setting up. We also have collision volumes, which you'll use quite a bit to prevent characters from walking into things or add collision around an object. You could use a box collision, or you could use it as a trigger, which we'll show you a little bit later in this video as well. But there's all kinds of components. There's so many here, in fact, that we're not going to go through all of these. We'll talk about some more of these, some of the movement ones a little bit here in a moment. But feel free to look through each of the components and the different properties at a later time at your leisure. So for now, all we're going to be using is a static mesh component, which is right here. We could select this from the components list, or we could actually filter if we're looking for something we don't know where it is. We can type it in and filter the list to get a bit of a more narrowed down list based on our entry. So we're going to be using a static mesh here. And as soon as we add it, it's going to ask us to rename this asset. And we're going to show you why you would probably want to do this. If we had multiple static meshes in our project, you're going to see that it just takes the name static mesh and adds numeric value at the end of it, which is not very useful. If we have a list of static meshes, it'd be hard to differentiate them based on this naming convention. So as a best practice, you're probably going to want to rename your static meshes, which you can do by either clicking on the actual name. It'll give you the ability to enter it right here. You can also hit F2 on it. That will also give you the ability. Or over in the details panel, under variable name, you can enter a name for it as well. But I'm going to hold off for doing that just for a second until we assign the actual static mesh that we want to use, which we can do from the details panel down here. So let's go ahead and assign a static mesh, which we can do by clicking this drop down and choosing from the available static meshes that we have in our project. Let's choose this book here. And once we do, we have the ability to assign different materials
book?
if we wanted to. There's other properties in here for simulating physics if we want this to be a physics object, collision, lighting, all kinds of different properties related to static meshes.
It is a book.
Now that we've assigned our book, I'm going to actually give this a better name from the variable name section here, which we'll just call this book underscore SM for static mesh. Inside the viewport, you can see that we have our book. If you ever get lost, you can press F to focus in on the object that you have selected over in the components list. It'll bring it up. So we have our book inside of here, but we also have this white sphere. So what is that? Let's talk about that for a second. That's what we call the default scene root component. So whenever you create a new blueprint,
he's referring, it's, so in UE5, it's this sort of thing now. I don't really know, like, what to describe that shape as, but this is what he's referring to now.
There's our book. It's quite small right now. But with this object selected, if we look over in the details panel, here is our blueprint, and we see we have all of the components available that we've added right here in this little component window, including our default scene root and the book. If we were to select the book right now, we could move the book inside the level like so, and you can see it updating in the properties value here. Clicking this option will reset it back to default. If I select the default scene root, that's going to move everything in the blueprint. You may have situations where you have components that you want to offset from their default position. That's how one way that you could do that is by using a scene root, or sometimes we use a scene component or maybe a billboard component. Billboard component is just a 2D sprite that will orientate towards the camera. As you rotate the camera, the light kind of faces the camera, so it makes it easier to select it as an asset inside of the level viewport. Let's go ahead and, for the sake of it, let's just make our book a little bit bigger. There's our first static mesh.
Oh my god, a super book. I like that idea.
If this was two static meshes, we could probably have the book open as it approaches the book. But for now, we're just using a static mesh as our blueprint. Let's go ahead and move on to the next one. We're going to create a skeletal mesh. Now we're going to show you a different way that you can add components now to a blueprint. So I'm going to right click and create a new blueprint class. It's going to be of the actor type again. And we'll call this the skeletal mesh underscore BP. And I'm going to double click and open this up. And again, we are inside the blueprint editor. There's our default scene root. I'm just going to dock this to the top here. And you'll notice again that we've opened the viewport. Whenever you first create a blueprint, it's going to open to the viewport tab. It's expecting you to add components to the blueprint. Once you've opened it or added components, it should open to the event graph where you can start adding your scripted functionality. I just wanted to point that out. Let's go ahead and add some more components here. I'm going to go ahead and click the add button. This time we're adding a skeletal mesh component. Okay, so we're going to add a skeletal mesh component. And I'm going to immediately rename this. We'll just call this character because I know I'm going to be adding a character. Like so. Let's go ahead and do one more thing. We're going to take the skeletal mesh component and we're going to make that the actual root. So instead of having this white sphere as the scene root, we can also make any asset the root as well. So I'm dragging that to the top. And now this is our actual root component. It also gets rid of that little sprite. Let's go ahead and assign our skeletal mesh. We're going to do it a little bit differently than we've done before. If we select the skeletal mesh component and we look in the details panel, now we have different properties that are related to skeletal mesh components, including the ability to assign our skeletal mesh. Now we could click this drop down and select from all the skeletal meshes that we have in our project, similar to what we've done with our static mesh. We're just going to show you a different way just so that you know all the different ways that you can do this. And then you can find the way that is most comfortable for you. What we're going to do is we're going to go to the content browser and we're going to filter for all of the skeletal meshes inside of our project. Looks like we have two. I'm going to select this one here because it looks more like a character. With it selected, if I go back to my blueprint now and the skeletal mesh property, I can click this icon here to use the selected asset from the content browser. So if I click this button, this could be useful if you have two windows up and you have something selected in the content browser. You can hop back over and just point directly to it. Another thing that you could do is you could drag a skeletal mesh or any object actually into the components window like so. That will also add components. So another way that you can add components is by dragging and dropping.
I actually didn't know you could do that.
Windows and content browsers up on one and your blueprints open on another. You can just drag all the components that you need into your blueprint. I'm going to delete that because that's not doing us any good. So I'm going to pop this back up. We have a character in here now. Let's go ahead and change some properties for the skeletal mesh. With it selected over in the details panel, let's go ahead and give it an animation. So we go to the animation section. Under animation mode, we're going to change it from an animation blueprint to just using an animation asset that we assign. Animation play, we can choose which one we want. This character has some animations in it, so we're just going to choose the idle here, and our character starts idling. We could also set properties like whether it should be looping, if it should be playing at all, initial position, etc. Again, feel free to jump through and look at all the different properties that we have for each of the different components. That's all we're going to do for this blueprint. Short and simple. We're going to compile, save this, close it out. I'm going to clear our filters and go back to our folder with our blueprints in it. And let's go ahead and just drag that in. Now what we should see is once we play inside the editor here, our character is just kind of idling. Now we could add some additional blueprint script to this so that when the player approaches, maybe the character turns and waves at us or does whatever we want. All of that can be done through blueprint script. But for now, we have a simple blueprint with a skeletal mesh component that is animating. Take that a step further. If we look over here, we're using the same skeletal mesh, still animating in an idle position. However, we've added some additional components to this to give it a little bit more functionality. And that's the power of blueprint. So as I approach this character, we're going to see a light comes on above his head. The character kind of starts rotating around. Now this could be useful if you're an animator and you want to look at different animations for a character. We could set our character up on a turntable style setup like this, which allows us to kind of walk around the character and look at the character from different angles as it's rotating around. If we move away, the character stops and a light goes off. So we've done this through Blueprint. And we could extend this even further. We could give our artist friends the ability to switch animations that they're viewing inside the details panel, speed up or slow down the rotation rate, pause it, etc. Step through animations, just kind of view animations for our characters. Again, all doable through the Blueprint visual scripting system. But let's actually take a look at this blueprint. So we can select it in the level here. We can go to Edit Blueprint, or we can right-click on it and choose Edit as well. It'll bring up the actual blueprint asset. Now again, brought us to the event graph because we already have components and we've already actually done some script here, but I'm going to hop to the viewport just to show you what components we have. We have the skeletal mesh like we had before. We also have a trigger, which is a sphere collision, which we've named trigger, a point light, and we also have this rotating movement component. Now one of the other things that I wanted to show you that I forgot to show you in the last setup is the ability to establish parent-child relationships with components. So here we have our trigger, here we have our point light. If we were to take our point light and left-click and drag it and drop it on top of the trigger, it now becomes a child of the trigger. So whenever we move the actual trigger, the light will move with it. So this is useful if you want to establish parent-child relationships. You can do that just by dragging and dropping. You can undo that just by dragging it off of its parent like so. Just wanted to point that out. So essentially what we're doing with this blueprint is we have a trigger, and what we're saying is when the player enters this volume, take this rotating movement component, set the rotation rate to something like 20 so that our character starts spinning, set it back to 0 so that it doesn't spin. and we're also turning the light on and off as well. So how is this actually working? If we look at the trigger and we go over to the details panel and we scroll down
I guess.
below all the different properties that we can change for that trigger, we have what we call events. So events will fire off blueprint script. And if we look, we have two options that we've already enabled called onComponentBegin overlap and onEnd overlap. So essentially, when we begin overlapping this volume, do some script, end overlapping, do some other script. And we can get to those by clicking the view button, which if we go to the event graph, it'll take us right to that node. And here is the script for that blueprint. It's a very simple script. Essentially, as we mentioned, overlapping volume, setting the rotation rate to 20, turning the visibility of the point light to on, and when we end, setting it back to 0, and turning off the light. And that's our simple script. Now, if we look over in the My Blueprint panel and expand the components section, all of the components that we've added are going to be available from the components window. And this gives you the ability to do things like add events for components. So for our rotating movement, we can add some different events. For our point light, we can add some events, trigger, and our are going to be available from the components of the point light to on, and button, which if we go to the event graph, and if we look, we have two options that we've already enabled called onComponentBegin overlap and onEnd overlap. So essentially, when we begin overlapping this volume, do some script. When we end overlapping, do some other script. And we can get to those by clicking the view button, which if we go to the event graph, it'll take us right to that node. And here is the script for that blueprint. It's a very simple script. Essentially, as we mentioned, overlapping the volume, setting the rotation rate to 20, turning the visibility of the point light to on, and when we end, setting it back to 0, and turning off the light. And that's our simple script. Now, if we look over in the My Blueprint panel and expand the components section, all of the components that we've added are going to be available from the components window. And this gives you the ability to do things like add events for components. So for our rotating movement, we can add some different events. For our point light, we can add some events, trigger, and our mannequin. Let's go ahead and compile and save this and close it out. And that is a blueprint with multiple components. We've learned that there are different types of components and that we can add them to our blueprints. We also ran through the different ways in which you can add components to blueprints, adjusted some of the different properties, and talked about how you can use events to fire off some blueprint script. If you need to, take some time and continue looking at the different types of components available and their properties, as having a solid understanding of how components work is a key concept in blueprint visual scripting.
Oh, we going on to the next? What is this one?
In this video, we'll take a look at the different types of blueprint graphs that
Just gonna try and like rush through these.
The basics of navigating those graphs so you feel more comfortable moving around within the blueprint editor. So here we are inside of the editor, and we have two stalls here with two different blueprints. One of them uses the construction script, and the other uses the event graph. And we're going to take a look at both of those more in depth here. So let's look at the first one here. They're both spotlights, but they're slightly different. Let's select this first one here. Inside of the viewport, you can see over in the details panel that we have all kinds of different components that are being used to make up this spotlight. So we have the different mesh pieces. We also have a light that is being used to project light into the actual environment. Below all of that, though, we have a section called default, and we have some properties in here that we can adjust. These allow us to change how this light actually functions. So here, we're adjusting the yaw, adjusting the pitch. Here, we're adjusting the light radius, and we can change the color if we wanted to. Turn it off completely. And we can adjust the light beam, which is like the light shaft that you see there. We can adjust the opacity of that. How is this working? If we select this and we go to the Edit Blueprint button and open in the Blueprint Editor, it's going to open up to the Event Graph. If it doesn't, go ahead and click the Event Graph tab, because I wanted to take a moment to describe some of the methods that you'll be using for navigating your graphs before we break down the construction script. Inside of our graph here, it's completely empty. You see at the top it says right-click to create new nodes, but we're going to right-click and hold in the graph. And as you move your mouse button, that's going to allow you to drag and kind of move around the graph here. So this is going to be the way that you move the graph. If you use the left mouse button and hold, what you're going to get is a selection box as you drag. So if you have a bunch of nodes in your graph, and you want to select them all, you can make a selection box around them and then move them wherever you want. That's how you're going to be doing selecting. If you mouse wheel down, that's going to zoom out, so you can get a wider view of your node network. Mouse wheel up will zoom in. It will stop at a 1-to-1 ratio here, so if you wanted to zoom in even further, you can hold Control and mouse wheel up. That's going to allow you to zoom in past that 1-to-1 ratio. And that's really the basics of navigating the graph. You can feel free to get comfortable.
Why, this uses construction.
Zooming in and out. But what I want to do now is actually add a node and talk about connecting nodes as well. So right-click to add new nodes. If I right-click, we're going to get the context menu. Okay, so the context menu is going to give you contextual suggestions for nodes that you can add to your graph based on the type of blueprint that you are in and the things that you have selected in your blueprint. So for example, if I were to go to the spotlight here and right-click, now we're going to get the ability to call functions on the spotlight. If I select the mesh, now we can call events for the mesh, as well as all the other nodes that we can add as well. If we right-click in the graph again, there is the ability to turn off context sensitivity, which you can check this option here or uncheck it to turn it off. That's going to give you all the nodes that you can add. Now, you do need to be a little bit careful with this based on the type of class that you are working in. Some of the nodes that you try to add may or may not work. So we're inside of an actor class right now. If you try to do maybe some networking stuff or some other types of functionality that isn't relevant to actors, then you may get some errors. So as a best practice, I recommend that you keep this on until you're a little bit more familiar with using Blueprint. So let's go ahead and actually add our first node. we're going to right-click, or in the context menu, we're going to add an event. So I'm going to click this button to expand some additional options, and we're going to add the event begin play. So event when play begins for this actor. Go ahead and add that. Once we add that, it's going to give us a node inside the graph here, our first node, which we can select it by holding it and left mouse button dragging around where we want to move it. We can deselect it by clicking off of it as well. So it's got 2 pins on it. I don't really want you to worry about the delegates right now. We don't need to be too concerned with those. All we need to be concerned with is this pin here, which is the executable. Now events are what kick off Blueprint script. Whatever we have connected to this wire will get executed. Now we're creating wires by left-clicking and dragging off of this pin. And when we do so, when we release, it gives us the ability to add a node to connect to this automatically. So we can search through this list and add different kinds of nodes. For the purposes of testing, I'm just going to search for a node called print string. This is a utility node. Essentially what it does is it prints a string to the log and optionally to the screen. So we use this quite a bit for debugging and testing our blueprints. I'm going to click print screen to add it, and you can see it's already been connected. Now if for some reason you want to disconnect this, you can hold the Alt button and left-click on either executable wire that'll break the connection, at which point you can reconnect it by left-clicking and dragging and making the connection like so. Now we could change the string, what we want it to print to the screen here. You'll notice that it has an out executable wire, so we could add something to the end of this if we wanted to. But for now, we're going to leave it just like this. This is our simple first blueprint script here. I'm going to compile and save this, close it out, come back to the level editor here. When we play it in the editor, we should see in the upper left here the text hello. So let's go ahead and play. And
There it is.
It says hello.
You may not be able to see.
We've done our first.
You can sort of see.
Scripting. I'm going to go back to this.
Not
blueprint
really.
and edit it. I'm just going to delete this because that was just for testing and getting our feet wet with making connections and adding nodes. Let's hop over to the construction script and take a look at a node network that has already been set up that gives us the ability to customize this particular spotlight. And the reason that we can do that customization is that we have what we call variables that allows the user to define the property value of these variables that we set up. So you can see we have yaw pitch, all those variables that are displayed inside of the details panel here that we can tune and tweak the way that this light functions. And the reason that we can do that is we've set these variables to be publicly editable. Now, publicly editable, you can make them publicly editable or not by clicking this eye icon here. So say, for example, we don't want the users to be able to turn the light off. We can turn that button off. You'll see that the construction script actually fires when we make changes. That's one thing that is important to note with the construction script is that it fires whenever you make changes inside of the editor. It also fires once at runtime. So as soon as you start your game, the construction script will fire again as well. Let's turn this off. See, it fires. We compile. And we go to the level editor. Now in the details panel, we don't have the ability to actually turn this off. So this is a way to limit customization on some of your blueprints. If you are setting up tools for level designers or artists, even for yourself, you can enable the variables that are publicly editable or not inside of the My Blueprint panel here. Take a look at the construction script here, how things are working. Don't be alarmed if you don't know what some of these nodes do. Looks like whoever set up this blueprint did a good job of commenting our nodes network here. You can add comments to any block of script inside of your blueprint, and it's very handy for allowing people to come into your blueprint and see kind of what's going on from a high level without really having to understand what each node is doing. Adding comments can be done just by making a selection box and hitting the C key will allow you to add a comment. I put a comment inside of a comment, which probably wasn't a good idea. We don't need that. Here we have a section of nodes that allow us to apply pitch and yaw values to the spotlight meshes. If the turned off variable is on, then we're going to turn the light off. If it's not on, then we're going to set the material for the actual spotlight, set up the color, as well as the light beam. So that's essentially how the construction script is being used. So let's go and close this out. Now you could use the construction script to do other things, like if you have a fence, for example, and you want to dynamically add additional pieces to that fence, kind of spawning in or adding additional static meshes, you could set that up. An example of that is actually inside of our content example projects, if you want to take a look at that. But again, the construction script can be used to create prefabs that you can tune and tweak inside of the editor. The next example will allow us to look at how the event graph works. I'm actually going to back up a little bit here and play in the editor to just demonstrate this. So it looks very similar to the light that we had before, except this particular blueprint uses the event graph to determine whenever the player is near the spotlight, and then it tracks us and follows us around.
I like that.
We're using the event graph to do this. Let's take a look at how that's working. So we still have our customizable properties in here that we can set up. If we go to edit this, we go to the blueprint editor here, and take a look at the construction script. It's very similar to the one that we had before. But on the event graph, we have quite a bit more script that defines the logic of how that light knows when we are in range and what to do and how to manipulate the camera to actually follow the player. So there's all kinds of script in here. We're not going to go through this in detail, but just know that the event graph is used at runtime to update scripts and provide information that can be used to update your blueprint scripts, essentially. What I want to do is talk about another type of graph that you may encounter or can use at your disposal when working with blueprints. The first of those, let's go ahead and select all of these nodes here. If we right-click on a node, we have the ability to create some organizational graphs. And what I mean by that is, let's go to collapse to function first. We have all these nodes here, and if we select collapse to function, what it's going to do is populate it into a single node for us. So if I Control Z to undo that, it's just a way of organizing things for you. So instead of having all this node network, you could take this particular one and right-click on it and collapse the function. So now it's just a single function. And it actually adds it over in the function section here, which you can rename this to something else a little bit more descriptive, which this determines whether the player is in range or not. So I would probably call this is in range or something like that. And if we go back to the event graph, now we have one node that does all of that for us. So it's very similar to what we had before. It's just collapsed into a little function here. Another thing that we could do is let's take this section down here maybe. All of this information down here, all it really does is determine the rotation values to use for the spotlight mesh. So it's basically getting values for us to determine the rotation. So if I select all of this and I right click on it and I collapse it to a macro, similar to what it did with the function, it collapses it down to an individual node. Now you notice this one has no inputs, whereas our function actually has an input. That's one of the advantages to macros. They don't necessarily need to have an input coming into it. This particular function is just getting information for us and then spitting it out as one of these two values, at which point I would probably rename these as well to something a little bit more descriptive. So that's a macro. Again, that will add it over in the My Blueprint panel, which we could rename this as well, which we could say get rotation values or something like that. As always, we can double click and open that graph like so for a function, or double click and open this graph as well. The last one that we'll talk about is collapsing nodes. So if I select all of these nodes here and I right click and I collapse these nodes, it's going to collapse them down into a collapsed graph, which we can give this a name. We'll just say it smoothly rotates spotlight.
What do I've
double click, open it up, and there's all
collapse
nodes
nodes?
that we have.
I've never seen
Back
this.
to our event graph. Well, you can see how we can organize our graphs a little bit tidier by using these different graphs. The advantages to some of these, the function, this is something that you can call from an external blueprint because it's a function. You can tap into this blueprint and call this function. As with a macro, the macro is more of a utility that you can use within this particular blueprint. You're not necessarily going to be calling it from external blueprints unless you set up a blueprint macro library, but again, that's outside the scope of this particular project. Collapse graphs is purely a way of condensing a particular graph. The good thing about the function as well, too, is that you can take the function and add it to different sections. So if you have something that you're doing multiple times, you can make a function for it and then just call that multiple times wherever you need to inside of your graph. The same thing with macros. Macros can do that as well. Collapse graphs, you cannot do that with. Let's go ahead and close this back out. We talked about construction script and event graphs. Now that we've covered how to move around the blueprint editor graphs and the different types of graphs that you'll be using, you should have a better understanding of what each graph can be used for. And if you need to, you may want to take some additional time exploring the graphs and practice navigating before moving on.
That's cool. I've actually never seen the collapse. Like, I've never used that. Never thought about it. I think pretty much anyone who's played with blueprints has done macros and functions before, but alright. Save. Next, we got a quiz. Start. You need to add a trigger volume to your scene. With a blueprint actor, the trigger then becomes a blank. Wait, what? Oh, within a blueprint actor, the trigger then becomes a component. If you want to modify blueprint variables within the editor, what type of variable do they need to be? Wait. Modify blueprint variables within the editor? Public? Designer has asked to be able to modify a blueprint actor's properties and see the changes appear in editor. Where would these properties be updated within the blueprint? So, again, a designer has asked to be able to modify a blueprint actor's properties. Okay. And they want to see the changes appear in editor. So you can do that in the construction. Complete. Oh my gosh, we did it. What is this? Caveats?
In this video, we'll take a look at some of the different types of blueprints you'll be working with.
Oh wait, no. Exploring different
Here we are
types.
inside of the editor, and we have several different stands with all kinds of different blueprints that we're going to be looking at. Starting with our first stand here, 5.1, and the level blueprint. So essentially what we have is, we play in the editor here, we have the ability to walk over and step on this button, turning on these gears, and the light on the button comes on as soon as we step off.
You got some gears. Oh god.
This up inside of the level blueprint. So if we escape out of this play session here, to get to the level blueprint, as long as we're in the main editor viewport, across the top, our main toolbar, we can go to the blueprints button, and about midway
Hold
down, we have
on.
the ability to open the
Can't
level
I
blueprint.
do...
Now, the level blueprint is a level-specific graph that you can use to script level-specific functionality. We'll talk more about this in a moment. But for now, let's open the level blueprint. Inside the level blueprint, we have some script that's already been defined and being used to set up some of the other demo stations in this particular project. One of the things that you may notice about the level blueprint is that it doesn't have a components window, as we cannot add components to the level blueprint. Therefore, it doesn't have a viewport tab either. All it has is the event graph.
Spawn it.
Script
Camera.
level-specific functionality. And what I mean by level-specific functionality is
Well-
that anything that we do inside of this particular graph
Oops.
is going to be bound to the level that we do it in. So if we create a new level, we'll have a brand new level blueprint that will be completely empty. Let's take a look at the script that's being used to turn on our button. So here is our 5.1 script that we've commented out. We have a trigger box that is being used to
That's
determine when we overlap it.
pretty
As soon as we do,
cool.
Turn on the button and also turn on the gears. As soon as we leave the volume of the trigger box, turn off the button and turn off the gears. And that's being done here inside of the level blueprint. So let's hop over to the other stand, the 5.2 stand, which is an actor blueprint, which looks very similar to the 5.1 stand.
Ah!
If we play inside the editor, so we can do the exact same thing. We can step on the button, the gears turn on, and that turns off, just as we'd expect. But we've done this as an actor class blueprint. This may be a case where if you are doing something that you want to reuse in your level or use in multiple levels, you may want to use an actor class blueprint as it's more modular. Anything that we do inside of an actor class blueprint will be bound inside of the actor class that we do it in. What I mean by that is select our blueprint here and we open it up. Here is all the script that is being used to determine how to turn on the gears and turn on the button. It's all done inside of this actual blueprint. We have the components window where we can add all the different bits and pieces that make up the blueprint, such as the button and the trigger box and the gears, etc. And that's all being done inside of this blueprint. And what's handy about that is that we can select this blueprint. We can drag out another copy of it, like so, making sure that it is flat on the ground, something like this. And if we play, we can walk over this button and those gears will turn on. We can just jump off of that and come onto this one and those will turn on. That's one of the benefits to using actor class blueprints is that we can quickly and easily make duplicate versions of this inside of our level, and the scripted functionality would just work. If we were to do that inside of the level blueprint, try to copy this stuff out, we would need to, each time inside the level blueprint, provide that scripted functionality. And not only that, when we switch levels, we would lose all that functionality. So the level blueprint is primarily for level-specific things that you need to do, kicking off initial script potentially, but you're probably going to want to stick with actor class blueprints because it's a little bit more flexible and modular in that regard. So I'm going to hop over to the 5.3 stand, and we're going to take a look at animation blueprints now. If I play in the editor here, and I walk over to this button, we now take control of a character that we can actually walk around with and jump and do all kinds of fun stuff with. As soon as I go back over the button, we lose control, and there's our character just standing.
It doesn't work.
Let's take a look at
That one doesn't work.
blueprint. So to do that, I'm going to select the character in the viewport here, and we're going to go to the details panel under animation class. We're going to browse to the animation blueprint that we
See,
already
like,
used.
this works,
It'll take me to the animation blueprint. As soon as I double click
but
to open it up,
that
it's a little bit
doesn't.
different. Let's go ahead and make sure that we are on the event graph, and let's maximize this so we can see it as well. It's a little bit different. This particular asset is used in the aid of creating animation logic for characters, whether you're controlling them or not. You could do that inside of an animation blueprint. The event graph of an animation blueprint is used to define the moment-to-moment variables, things that can change while your application is running, and once you update those variables, those can in turn be used to drive which animation pose your character would be in.
I noticed
One of
the
animation poses is done on the
button.
anim graph. So if we open that up, here's our anim graph.
Oh.
The anim graph has all kinds of different stuff in it that allows you to blend between different animations. Here we have the ability to set up a state machine, so we can be in different states, so we can be idling or running,
Interesting.
etc. The anim graph basically allows you to define your moment-to-moment final animation pose, while the event graph, similar to an actor class blueprint, allows you to update your moment-to-moment variables at runtime. So I'm going to close this out, and we're going to move on to the next stand, which is 5.4. This is for creating UI elements in your project. So if I play in the editor here, as soon as we walk over to the button and stand on it, we have a little bit of a UI pop up in the upper left-hand corner of our screen, which says health and energy, and they look like they're depleting, so I better get off that button. And as soon as we step back on, it resets. This uses what we call Unreal Motion graphics inside of UE4 and what's called a blueprint. So let's take a look at what that looks like. To do that, we're going to have to actually go back to the level blueprint because I used the level blueprint to set this up for us. I'm going to open the level blueprint first. We scroll up here. We have at the begin play, it's doing some stuff to store the player character's transform for the playable character. But to the right of that, we are creating a HUD. So if I click this browse icon, it should take us to it in the content browser. So let's go ahead and open that up. And this is a widget blueprint. So it looks a little bit different than some of the other blueprints we've been working with. It has a graph, which is called an event graph, which is very similar to
Wait,
some
what?
other event graph that we've worked in. Right-clicking and holding will allow you to drag around in the viewport, as we've done before. But you can see it's a widget blueprint, so there's UI-specific things that we could do inside of this graph. Not to mention that it doesn't have a components panel or components window. It doesn't have a viewport. It has a designer tab. So this is where we can lay out visually how we want our UI elements to appear inside of our project. And we could do all kinds of things like doing animation for those, all kinds of different UI elements that we can add, buttons and checkboxes, and all kinds of cool things that we can do inside of the designer tab. So let's close this out. And let's move on to the final stand in this particular video. This is not a new type of blueprint. It's still a actor class or whatever type of blueprint you base it on, but I wanted to illustrate why child blueprints are beneficial. So if I play in the editor here, we have a couple of different items that are kind of floating in the air. They're kind of your traditional pickups. As soon as I go over them, they kind of zoom in towards me and they print something in the upper left telling us what we've picked up.
Oh,
Let's take a look at how this was set up. We go to the blueprints folder and we have all of those assets.
you got a
We
cupcake.
have one called the parent. I'm going to go ahead and double click and open this up.
You restored some
Now,
health.
if I maximize this, this is just an actor class blueprint, similar to some of the other blueprints we've set up before, but all the logic is set up in here for what happens when we actually pick up the thing, how we get it to animate, etc. That's all done inside of this blueprint. Go to the viewport tab, we can see it has a mesh, has a trigger volume for us to enter, and a light. I'm going to close this out. We also have some other items here called child. If we open these up, script is a little bit different in here, but what's cool is that because we are basing this off of another class, we get to inherit all that functionality from the pickup blueprint. So all that functionality that's inside of here, we get all of this for free. We don't need to recreate that. This blueprint already knows what happens when we overlap that volume. It already knows how to animate the pickups. It already knows how to do all of that for us. We can come in here and script custom functionality that we want on a per pickup basis because it is a child. And in this case, all we're doing is saying, when we overlap it, go ahead and print something different for each one that we pick up. In this particular case, we pick up a cupcake. So that is a child class blueprint. And you can create child class blueprints by right-clicking on any blueprint and creating a child class from it. That will allow you to inherit all the functionality from the parent in your child blueprint, which is super handy. Depending on your background or interest, you may be working with all or just some of the blueprints we've covered. The key concept that they share, however, is that they all use node-based visual scripting to accomplish many of the same tasks that were once only available to programmers. So once you have the basics down, you should be able to experiment and create content within each type of blueprint. Before you continue on your journey in the world of blueprint visual scripting, I thought it best that we discuss some of the caveats that you should know about and consider along the way.
Definitely no
Blueprints are
caveats.
super powerful. Why don't we just do everything in Blueprint then? It's entirely possible, but there are some things to consider. One of those is that there is a cost associated with using Blueprint over C++ code. I don't want you to get too concerned with this just yet, but do know that there are certain things that will impact your game or application's performance more than others if they are done in Blueprint. For example, doing a lot of complex math or heavy operations on every frame, you may want to move this to C++ code, as Blueprint runs in a virtual machine to translate your Blueprint nodes into native C++ code, and that's where the cost is incurred. There's also no easy way to state this. C++ code is going to be faster than Blueprint, so you do not need the virtual machine to translate your code. It's also going to be a little bit more powerful, as there are some elements of C++ code that are not currently exposed to Blueprint, meaning that there are some things that can only be done in C++. Having said that, there are many games and applications out there that have been created entirely in Blueprint. Another thing to know, Blueprint is event-based, meaning some type of event starts the chain of other events or functionality to occur. That event could be the start of a game or application, when the player runs into a wall or picks up an item, for example. These are all events that could start or kick off your Blueprint script. And finally, I saved this one for last, as this is the one that you will probably encounter the most when first starting to work with Blueprint, is that Blueprint uses references to access data and functionality between multiple blueprints. So if you're not careful, you could run into situations where you return an invalid reference, which would produce errors. There's also the possibility of running into circular dependency issues, which I'll come back to in a moment. But first, let's take a look at how references work. So here we are inside of the editor, and we're going to take a look at a couple of examples with regards to references inside of UE4. So let's look at 6.1 here. So we have a button here, and we have a couple lights up here. When we go over the button, we want to turn on one of these lights. So if we play in the editor, and we approach the button, and we go over it, nothing happens. None of the lights come on. In fact, if we escape, we're getting a nasty little warning down here at the bottom, which we can click on. If we click the show message log, it'll give us a little bit more information. And we're getting an error inside of our blueprint, so our blueprint is not set up correctly. If we use the message log to our advantage, we can diagnose what's going on with our blueprint and where the problem may be. So the error that we received is that we are accessing none, trying to read property reference to light. What's really cool about the message log here is that you can actually navigate to the source of the problem directly from the message log. So each of these links, we can click on them and jump directly to the problem. So at the very end here, it looks like we have a function called turn on light. If I click on this, it's actually going to open up the blueprint and take us right to that node. And the problem that we are seeing is that we are attempting to access a variable, but we're accessing a null variable. There's nothing there. We're not accessing anything. And we are trying to read property reference to light. So if we have a graph here,
why are you trying to do that?
it's being called, and we are trying to read reference to light. So that's what it's targeting, but it's not getting any data that it can use. So let's take a look at this. I'm going to close this out, and we're going to look at the blueprint in the level here. So here's our button, and when we go over the trigger volume, we want to turn on one of these lights. If you look at the details panel, we have a property called reference to light. And you can see it's currently set to none. So this is probably where the error is. We need a reference to which light we want to turn on. Even if we had one light and we want to turn on just one light, we still need a reference to the light that we want to turn on. So this is our problem. Now we could click the drop down and select from the list all the available lights. I can also use the eyedropper here to kind of pick one of the lights from the scene. So I'm going to pick this one here. Now that we've assigned that reference, we know that when we enter the trigger volume, we want to turn on this particular light. So I play now and I walk over to the button, I turn it on, the light comes on, and it fixes the error that we had. Conversely, we can choose the other light if we wanted to as well, just like so, and it would turn on the other light. So that is references for this first stand. We're going to look at 6.2 here and talk about casting, because this is something else that you might run into when working with blueprints. Now suppose we had something else in our scene that was a physics object, and suppose we move this over on top of the button, something like this, and if we played, the ball turns on the light. The physics object actually hits the button and turns on the light. Now suppose we don't want that. Suppose we only want the player to actually go over the button to turn on the light. This is where we could use what we call casting. So we'll move that back over here for a second. And I set this blueprint up just a little bit differently. If we open this up and we right click on it and open the blueprint, What we're going to have in here is a little bit different script than the other one. As soon as we overlap the collision volume, we're now running a check to see what is it that overlapped the button. And we're doing that by taking the other actor, the other thing that overlapped the collision volume, and using what we call a cast. We're casting to see, is it the player that overlapped it? So another way to explain casting is you're checking to see if one object is another type of another object. So we're saying, is the other actor the player? If it is, then go ahead and turn on the light. If it's not, then we're going to print to the screen that we failed. So let's actually test this out. Let's make sure that we have assigned a reference to a light. So we'll turn on a left light here, like so. And if we take this ball over and drop it on top, we should get a failed. It doesn't turn on the light, which is what we would expect. However, if we move the ball out of the way and we play and we go over the light, or the button should turn on the light, as we'd expect, because it casted to and checked, is it the player that overlapped the button? But what we could do if we wanted the ball only to overlap the button and turn on the light, what we could do is we could right-click, edit, and instead of casting to the player, we could check, if we look in the outliner here and we select the ball, we can see that this is a static mesh actor. That's what this object is that we have selected. What we could do is say, is the other actor cast to static mesh actor, like so. And if we connect that up, connect this up, now we're saying, is it a static mesh actor that overlapped? We just drag that off screen for a second. And if we move this on top, like so, now the ball can turn on the light. So that's what casting is. You're kind of throwing out a net, trying to see, is the other object that you are casting to of a particular type? And that's what we've done here to see if we want the player or another object to turn on this button. Another issue that you might run into is what we call circular dependencies. And these occur when you have two or more blueprints.
Circular circular dependencies are my favorite.
Blueprint A and blueprint B. So say, for example, blueprint A casts to blueprint B to access a variable stored inside of it. Blueprint B then casts back to blueprint A to maybe call a function or access a variable inside of it.
This is a problem in C++ too, though.
All of the dependencies that it has, since it depends on blueprint B, it also begins to load. As blueprint B loads, it then depends on blueprint A, so again, it loads blueprint A, so this vicious cycle continues. And because both blueprints depend on each other, this may significantly increase load times, or it may fail to load entirely, resulting in errors. Again, these things are things to consider, things to keep in mind when working with Blueprint, and Blueprint does a pretty good job of warning you when invalid references or circular dependencies are detected. Don't be alarmed, however, if you run into any of the caveats we've mentioned. Practice makes perfect with Blueprint. The more you use it, the more you'll be accustomed to the nuances of the system and feel more comfortable in your scripting ability. That will do it for this video. You should now have a high-level understanding of some of the things to watch out for when working with Blueprint. As with anything, do expect a little trial and error to start, and that's perfectly fine. You do have enough knowledge, however, to jump into the editor and start your hands-on work with Blueprint visual scripting. So have at it, explore, and return to this series if you ever need a refresher.
Yeah. Wrapping up.
So we reached the end of the Blueprint Essential Concept series, and we've covered quite a number of topics related to Blueprint visual scripting in Unreal Engine 4. We talked about what blueprints are and the concepts behind them. We learned that Blueprint is a compiled visual scripting system completely embedded within UE4 that enables you to do a bit of programming, but just doing so in a more visual way. We talked about the different ways that you can create blueprints and took a tour of the UI, explaining all the bells and whistles of the system. We also spent some time working with components and talked about how they are the bits and pieces that make up our blueprints, that they can have functionality or properties attached to them that we can access or modify, or it could be used to create prefabs for us, like a building blueprint that has several components that construct the building, but doesn't actually have any scripted functionality within it. We explored the different types of blueprint graphs and what they are used for, mostly working with the event graph, which evaluates and updates at runtime, and the construction script, which evaluates during editing anytime the blueprint is changed, and can be used to create level editing tools to make your life a little bit easier. We touched on the different types of blueprints, the level blueprint versus class blueprint, the UMG widget blueprints for UI, and the benefits of using child blueprints. We also talked about some of the caveats to using blueprints, such as the cost of blueprints versus C++ code, and working with references and avoiding circular dependencies whenever we can. We hope that you enjoyed this series and have a better understanding of Blueprint visual scripting inside of Unreal Engine 4. Jump into the engine now and start experimenting with Blueprint, as the more you use it, the more comfortable you will be with the system.
Okay. For your visualization, you want to allow all the doors to automatically open and close as the user walks to them. What type of blueprint would be best for this type of functionality? A blueprint actor? You have selected a few meshes in a scene and want to make them into a blueprint actor. What is one way to do that? Select the meshes, click on blueprint on the toolbar, then convert actors to blueprint. That was... well, that was easy. Holy heck, we did it. Well, that's the first one. Oh, where do we find... I don't know what they all are. Okay. Okay. Can you tell me what next? Oh wait, I earned a badge? Where's the badges? Is it just the achievements? Oh, hey. Blueprint Journeyman. Hey, we did it. We got the first one down. Oh, okay. Boom. Journeyman complete. Alright, so the next step is actually becoming a ninja. Okay. So... Oh, there are 2 courses we have to complete for this one. Editor Fundamentals? I will start course. And then after that, Blueprint Kickstart. Which I may or may not have already done, I don't know. Alright, start course.
I'm going to talk a few minutes about selecting and modifying actors.
Definitely going 3x.
Show you how to modify actors, but I want to be a little bit more specific. Once again, if I go to my modes panel and I grab a cube and I bring it into my level, and I hit the W key, we can transform this actor by selecting either or any of these orthogonal manipulators, and then I'm now translating it along the specific axis of my selection. I can constrain it along 2 axes by selecting one of these little corner handles, and now I'm constraining the movement to, in this case, Y and Z, or down here at the bottom, I can constrain along the Y and X, or in this case, I'm constraining along the Z and X. I also have virtual manipulators. So if I hold down the control key on my keyboard and I use my left mouse button, now constrained to the X axis, and if I use my right mouse button, it's constrained to the Y axis. And if I use both my mouse button while holding down the control key, and now constrained to the Z axis. And one of the things that can be really helpful and quite powerful is to also be able to lock my viewport while I'm manipulating an actor and constrain it to the actor that I'm moving. So in this case, what I'm going to do is I'm going to hold down the Alt key and make a duplicate of this cube. So there's 2 of them right next to each other. And let's say I want to make sure that I finesse the edge of these 2 together. And I might turn off snapping to do this, or at least bring it down to 1 unreal unit to move this actor right next to the other actor. And so maybe I will move my camera right on the edge. And now I can hold down the control and the shift key. And now as I move this actor using my virtual slider, you can see that my camera is constrained basically to this actor. And I can move that along anywhere, move it right to that very edge. And once again, I can constrain it so that I can very precisely snap it along right next to the other box. And once again, I continue to refine this just by making sure that it is exactly where I need it to be and no further. And if you need to turn off snapping, you just move it very precisely by zooming in and constraining the camera. Now, of course, if I hit the E key, I can constrain to my rotation. And if I reset my rotation and I hit the R key, I've got these constraint manipulators also for scale. I get planes to constrain scale along an XY or an XZ or a YZ axis, or I can uniformly scale by grabbing the center. So that's how I manipulate actors using my transforms and by using virtual sliders. Now, selection can also be something that can be very helpful to be aware of if you need to select instances of actors. In this case, for instance, I've got multiple spheres in my scene. These spheres are all being used with a different material on them. Let's say I want to select all the spheres inside of my level here. If I right click over them, you'll see that there's a selection menu. And the selection menu gives me many options. I can select all, I can unselect all, and this will select all the things in the level. I can invert the selection. So right now I only have 1 sphere selected. I can invert the selection and now it selects everything but that sphere. I'll select the sphere again, go back to the selection menu. I can select any medium children, descendants, a variety of other selections. But by far one of the most powerful ones is to be able to select all matching actors of class. Let's say I want to just select all the other spheres, or I select this cube and I just want to select all other instances of that cube. This can be really, really handy if you want to alter materials or change the scale of all the spheres, for instance, at the same time. So let's select all of these material spheres and decide, you know what, I just need them to all be a little bigger, 1.2 in the size scale. Now it's a little bit better. The art director would prefer that than smaller spheres in the scene. So be aware that it can be really handy. Additionally, if I were, for instance, to select all of these cubes and select all matching cubes and navigate over here to the cube that has the actual manipulator, you can see that the pivot point for all these cubes is in the corner here. Let's say that I wanted to change and alter the pivot settings for any of these. Now you can't actually change the pivot to an actor inside of Unreal Engine without sending it back out to your digital content creation tool. But by holding down the Alt key, you can, using your middle mouse button, temporarily alter a pivot point. So if I hold down my middle mouse button and hold down the Alt key, I can temporarily alter a pivot point. So now I can actually manipulate all of these, and I'm going to undo that, and once again move that. Because you can see that if I select nothing and select the cube, and then once again reselect all of those actors, the pivot point is moved back to the actual asset's origin pivot point. And this is true for single selection or multi-select. Once again, holding down the Alt key and middle mouse clicking, I can alter the pivot. Now if I hit the rotate manipulator, I can move it from a different pivot. But if I
Hang on a second. How did you do that? Hold down Alt.
select that actor, the original pivot has moved back to where it got imported or created from. So be aware of that. We do that so that if this asset again, reselect all of those actors. The pivot point is moved back to the actual assets ordered pivot point. And this is true for single selection or multi-select. Once again, holding down the Alt key and middle mouse clicking, I can alter the pivot. Now, if I hit the rotate
Oh,
pivot
Alt
I can
middle
move it from a
mouse.
different pivot. But if I reselect that actor,
Whoa!
the original pivot has moved back to where it got imported or created from.
I'm gonna forget
Be aware of that.
how
We do that so
awesome
that
that
if
is.
this asset is also placed in a separate level, that it doesn't accidentally get modified because I've altered it in this particular level and saved the alteration of that pivot. There are many other bits of functionality that you can do. You can see here that there is a pivot right-click menu that allows you to reset the pivot offset and also center the pivot on the selected actor. So in the case of this cube, I can right-click and center the pivot on the selected actor. And in this case, it's not going to do it for me, of course, because I'm demoing it, but I can also manipulate the transform, mirror the actor, and that can be really handy. Mirror along the z-axis. And you can see that that is being reflected here, mirrored along the x-axis, being reflected here in my transform. So if I reset the transform, it's going to go back to where it belongs. So mirror it back along the y-axis, and I believe it was originally scaled to 2. Not along all of them, but just along the single axis. 1 and 1, -1 there. So be aware of that functionality for manipulating an actor. It can come in handy.
Okay, that was actually... There was definitely something to learn in that one. That was pretty cool.
Let's take a moment and talk about the level blueprint. Now, I created a new level, and this level is just one of the default levels that's created when you create a new level. It's called the VR basic level, but it's really just kind of an interesting level with some nice metallic wall materials and some static meshes that, if we take a look at these static meshes, they're all cubes and cones and triangles and spheres that have their physics enabled. Now, what we're going to do with these actors is we're going to duplicate them and make a nice pile of them in the center of this room here. So here in the world outliner, I will select all of the cubes, and I'll select also the pyramid, and I think the ball is also selected. And why don't we make a duplicate of them by hitting my W key to transform and holding down the Alt key and just making a duplicate of them by dragging them up a little bit. And why don't we rotate them just a touch and hitting the W key again and dragging up another copy of them and rotating them in the other direction just a touch. And since they are all physics actors, they all have their physics enabled, I can go back in my world outliner and select all of them again, so they're all in my selection, selecting also my little pyramid shapes, and coming up to the play, and instead of hitting play, I'm going to hit simulate, and you'll see what happens. They all kind of fall into a pile and crumble down. They just kind of become a cool shape. Now you'll notice that if I hit stop, they kind of all go back to where they were, and that's not what I want. What I want is just to create a big pile of cool stuff. So let's go back and take the balls all the way down to the cubes, select them all again, and once again, control, select all the pyramids, and once again, hit simulate. Let them all come to a rest. Let's leave that pile there. And if I want them to stay in this position, I can just hit K on my keyboard, and you'll see that all the actors' final resting position will be stored there. So I can hit stop now, and instead of them going back to their original position where I moved them to, they're now sitting here and can come to rest at this position. They're all still physics actors. If I select them, you'll see that physics simulation is still enabled for all of them. Great. Now let's come over here to our modes panel and find a radial force. And I just start typing rad, and I get radial force, and I'll move that to the center of my level, and I'll change the radius to encompass mostly the entire room. And I'm also going to tick the box here in the impulse section, impulse velocity change, and I'll change the impulse strength to something like 3,500. All right, that's good so far. Let's just add one more thing for now. I'll come down here to my content folder, and I see that I have a mannequin folder. Let's grab in the mannequin folder, in the character folder, in the mesh folder, the physics asset, which is basically a representation of my mannequin character. If I hit escape, you'll see that there he is, just sitting in the space. Now, you'll notice also that my player start is kind of in the middle of that mess, and I kind of want to get my player start out of there. So I'll hit the W key, and I'll move my player start back into the corner here, so that when I now switch from simulate to play in viewport, I can sort of look at my entire scene. And you can see that my physics asset now just crumples to the ground. All right, I think I have my stage set. It's a good time to save. Click up here on the save current level, and it'll give me an opportunity to save. I might create a maps folder, and I'll call this my new boom map, and I'll put it inside of my maps folder. Now, basically what I want to do is I want to fire an impulse and activate that radial force. And I can do that a variety of different ways, but that radial force is sitting inside the level. Now, there are many different ways to access your blueprints, but there's one very special blueprint, which is called a level blueprint, which lives inside of this level. And one of the distinctions about that blueprint is it's aware of all the different things inside.
Really,
So
I
there's something
think
that
we
actor class
should
blueprints cannot do. It can
just
actually
try to
reach in and
use
talk to the things
this
in this level.
and-
Now, we access this particular blueprint in one specific place, which is here in the blueprints dropdown from our toolbar. And if I click on it, you'll see I can open the level blueprint
Just
here.
don't know how
So
to
I'll open the level
do.
blueprint, and it gives me access to the level blueprint here. And it gives me a couple of default nodes that I can use. I can use the begin play or the tick node. I don't really need those, so I'm going to go ahead and get rid of them for now. But what I do want is I want to access that
Oh,
radial
new
force that I
level,
placed in
hey.
my level. So I can go and select it. I can select it either here in the level, or I can select it from my world outliner here. And with it selected in the level blueprint, I can now right click. And you can see that in the very top section here, it says, what would you like to do? Would you like to create a reference to this radial force? And I can say, yes, create a reference to this radial force. And with this radial force selected, I can drag out from it, and I can type in impulse, or let's say fire. Actually, what I need to do is actually get the component for it. And if I look at the very bottom here, I get the actual radial force component. And the component is actually the element that is firing. So I can see that right here with it selected that I've got the radial force and I've got the force component. So I want to talk to this component. And with the component selected, now I can fire an impulse. Now I can fire an impulse based on a variety of different inputs, but I'm just going to hard code this input. And if I right click and hit the 1 key on my keyboard, you can see that I can bind that to the 1 key on my keyboard here. And it gives me immediate access to the 1 key, press and release. So let's connect the 1 key, the pressing of the 1 key, to the firing of the impulse and hit compile. And now the one other thing that I want to do is I want to take my
Oh
skeletal
no,
mesh
he
physics
does.
asset, and I want to roll down to the collision, and I want to generate an overlap event, which we're going to use in a few minutes. Insert the level.
Simulate?
And now let's push play. Now everything collapses, and if I hit the 1 key, wow, I get a nice explosion. Bang, everything's flying around. And there's my character, and you can see that he gets banged around every time I hit the 1 key. And all
So
the content's
then-
kind of flying all over the place. Cool. So my level blueprint is talking to my level. Let's hit the 1 key again. I'm gonna push
Confused
play.
he hit
Bang.
K,
That's a little exciting,
but
but it could be more exciting. Let's go back into my blueprint here. And after I fire the impulse,
Alt
let's also
K.
type in emitter.
Definitely not
Emit
Alt
or
K.
spawn an emitter at location. And because I have my starter content loaded here, you can see that I've got starter content. One of the pieces of starter content is a particle system called an explosion, so I can select it here in the emitter templates. And the one piece of information that it needs right away is where that emitter should
That
spawn.
was a left.
Now I can
Okay.
get that information here from the Radial Force component. So I can drag out and say get world location, and I can feed that to the location. So let's compile that. Stage set. It's a good time to save. I can hit the corner here to my content folder, and I see that I have a pulse section, impulse velocity change, and I'll change this. And I just hit K on my keyboard, and you'll see that all the actors, select them all again, and once again, Control, select all the pyramids, and once again, hit Simulate. Let them all come to a rest. Let's leave that file there. And if I want them to stay in this position, I can just hit K on my keyboard, and you'll see that all the actors' final resting position will be stored there. So I can hit Stop now.
So you have to
Instead of them going back
select
to their
them
original
all.
position where I moved them to, they're now sitting here and can come to rest at this position. They're also
Simulate.
physics actors. If I select them, you'll see that physics simulation is still enabled for all of them. Great. Now let's come over here to our modes panel and find a radial force.
And
I
then,
just start typing radial,
okay,
I get
so
radial
you
force.
have
I'll
to
move
have
that
them
center of my label,
selected,
and I'll change the radius.
and then you
so
hit
it covers
K.
mostly the entire room.
Gotcha.
And I'm also going to tick the box here in the impulse. Now, the one other thing that I want to do is I want to take my skeletal mesh physics asset, and I want to roll down to the collision, and I want to generate an overlap event, which we're going to use in a few minutes, and save the level. And now let's push play. Now everything collapses, and if I hit the 1 key, wow, I get a nice explosion. Bang, everything's flying around. And there's my character, and you can see that he gets banged around.
Oh god,
Every time I hit the 1 key.
that poor
All the
man.
content's kind of flying all over the place. Cool. So my level blueprint is talking to my level. Let's hit the 1 key again. When I push play, bang. Now it's a little exciting, but it could be more exciting. Let's go back into my blueprint here. And after I fire the impulse, let's also type in emitter. Let's emit or spawn an emitter at location. And because I have my starter content loaded here, you can see that I've got starter content. One of the pieces of starter content is a particle system called an explosion, so I can select it here in the emitter templates. And the one piece of information that it needs right away is where that emitter should spawn. Now I can get that information here from the Radial Force component. So I can drag out and say get world location, and I can feed that to the location. So let's compile that. And now when I push play and hit the 1 key, you see I get a nice little explosion there in the center. And that's kind of fun. Let's do a little bit of something here. Let's scale this up. And this isn't always a good idea, but just for the sake of making it a little bit more visually interesting, let's scale that particle system up to 2.5. Sometimes particle systems like this don't scale well, but let's give it a shot and see how it works in this level. Push play again, hit the 1 key, and this one seems to scale reasonably okay without my particle sprites going too crazy. You can see my guy likes to dance every time I fire the explosion. Let's do one more thing here with this explosion. We can also spawn or play a sound. Let's see whether it's play
The
sound or spawn a sound. Yeah, let's play sound.
mannequin
at
just
location. So let's see
ragdolling.
what
That's
sound do you want to play.
hilarious.
Fortunately, because we have a sound particle system, we also have an explosion sound actor that can be spawned, and it's going to ask for location as well. And I can drag out from the location that I used to spawn my particle system and drag it into the location as well. Now you can see that this wire kind of crosses over that node, and you can always create a reroute node in any blueprint by double-clicking on the wire, and that will create a little node that you can drag out to tidy up your blueprints a little bit. So let's try that now and see how that works. I can push play. Now, one of the things that's really cool about blueprints is that if I minimize this a little bit into the corner, we can watch it all simulate as I push play. Cool.
And that is pretty cool. Next.
Where we left off, we had created a small experience here by stacking our meshes in the center of this environment that we created, and we put Skeletal Mesh in the center, and we also created Radial Force. And if you recall, we opened up the level blueprint, and we wired all these things together using the 1 key. We brought in our Radial Force using the right-click menu, made a reference to the Radial Force, and we connected it to the impulse, spawned an emitter, and played a sound. If you missed this particular lesson, just go back to the video and you'll be able to catch up. Now moving forward, what we want to do is create a small mini game where we trigger all this and fire a cinematic. Now what I've done in between is created a small sequencer sequence, and I can open that up so we can take a look at it, create a folder with a little cinematic, and I've just double-clicked on the cinematic so that we can play it. And if I connect the camera to it and push play, you can see what it does. Just a little guy running across the top and jumping off the edge. Oh, that's all there is to it. Not a whole lot at all. Created a camera. I've given some parameters to the camera, changed the aperture and the focus a little bit. And then I brought in one of the mannequins. I've applied some animation to him. He runs across the top, and when he reaches the edge of the lip, he jumps right off. And what we want to do is we want to create an experience where we fire our radial force, and we make our physics asset leave the space. And what we'll actually do is we'll bring in a couple more of these. So if we want to find out where this actor is, all we can do is browse to asset, and we find out that this is our physics asset. So let's actually put a couple more of these in the environment. So we'll just drag a couple more in. Maybe we'll put one up top here and rotate it a little bit. Now why don't we put another one on top of this block over here, and maybe rotate it in this angle. And now we'll have 3 of these guys. And what we can do is make sure that these are all selected, all of these physics assets, and we want to go down into their details panel here in the collision section and make sure that all of these are generating an overlap event. Make sure that this box is ticked. Because what we want to be able to do is to put a volume inside of this space and make sure that these are overlapping that volume. So I can put a trigger volume in the space and make sure that it covers the entire play arena. So if I come down to the brush shape for that volume and kind of wiggle it into place, maybe 2500, along X and 2500, and maybe along the Z axis it's maybe 900. Now let's take a look at the size of that, and we can see that it mostly encapsulates my play space. Maybe 700 in height, that's good enough. Now this volume, this trigger volume, has the distinction of being aware of what's overlapping it. So what we're going to do is create a small mini game where this volume is aware if these physics assets, these characters are inside the volume, and once they leave the volume, let's have them trigger the cinematic. So I can't say it's a very fun game, but I think you get the idea. By using a level blueprint, we can talk to the volume and then have it trigger the cinematic. We'll select our volume, and we'll go back to our level blueprint, and let's access it. And one thing we can do is we can just call a reference to the trigger volume, which you'll see here. We also have the ability to add an event based on the trigger volume. So let's open that up, and let's see what its collision opportunities are. And we can see that we can on actor begin overlap or on actor end overlap. So let's take a look at this node. Now what this node allows us to do is that when something exits the volume or ends the overlap event, we can create some functionality. Now, some of the other stuff we want to do here in this level blueprint, first of all, is get a reference to all of those skeletal mesh actors. So let's call up the begin play node, which is available to all of our blueprints. So by right-clicking, we'll type in begin play, and we see that we get right here a reference to event begin play. And on the begin play, we'll drag out, and through the execution pin, we will get all actors of a certain class. And you see there's a utility node that says get all actors of class. Now, this is a really important and valuable node, but we want to use it cautiously. And in this case, we know that we're only going to call it on a class of actor that has realistically only 3 actors. So it's not going to have to search an entire massive game and find hundreds and hundreds of actors. In this case, we just want to find all skeletal meshes. So as I start typing skell, it finds skeletal meshes. And when we find skeletal meshes, let's find out that the output from there is going to be X number of skeletal meshes. So let's find out how many by typing in length. And we see that we have an array utility node called length. And we'll take the output of that and promote it to a variable. Now we can typically do this just by right-clicking from the output pin and promoting it to a variable. And we'll call this variable number of mannequins. And we'll connect the number of mannequins straight to the begin play execution pin. And you see that when I created this node, it added to my variable stack right here. So when the level begins, it'll execute event begin play. It'll go out and find all the mannequins, find out how many there are, and it will populate this variable. Now having that information, I can come back here to my trigger volume, and I can get the other actor, and I can type get class, and I can make sure that that class is equal to class equals skeletal mesh. I can come down here, make sure that it's equal to skeletal mesh. And if it's equal to a skeletal mesh, let's type in branch to make sure it meets the condition, connect that to our execution pin, and then we'll decrement. We will start subtracting all the skeletal meshes that it finds, so we'll type in decrement, and we'll decrement the number of mannequins that it finds. So we populated the number of mannequins here, and we'll start subtracting them, and we'll subtract them until we find 0. Once it's equal to 0, we'll branch again, and once that's true, then we'll play our cinematic. In order to get access to our cinematic, we want to make sure that it's available to us here in the level. If it's not in your level like this, we can go and find it in our level, and I'll just delete it here so we can find it again. We can just drag it into the level. Once we've got it in the level, make a reference to it.
I would like to
and you see that we have access to play sequence
learn more about the creating cinematics and stuff.
So let's see if this all works. I can compile and save my blueprint, close it, and give it a shot. So now all my mannequins collapse into place. We move around. There's one left. Get him out of the space. Now the cinematic plays. He jumps off, and I'm back. And like I said, it's not much of a game, but it's interesting that I managed to get all of these things to talk to the level and execute my final cinematic. Let's hit escape and try again. Here we are. We can move around, and now one key. Wow, one key went off right away. There's another guy in the corner. One key. Popping out, and there we go. Executing our final cinematic as he jumps off. Now, if we want to clean this whole thing up a little bit, we can go back into our level blueprint. Maybe right after the sequence plays, console command, execute console command. Let's try restart level. See if that works. Oh, we need a delay. Let's try one more time with a delay. We'll give ourselves a delay of however long the cinematic is. So let's open up the cinematic and see how long it is. The cinematic appears to be, let's display the cinematic in seconds.
Can't you get a variable that just pulls the length from the cinematic?
Well, unless it works. We can tune a little bit, but you get the idea. Now, if I close that, the guy in the corner will disappear and we're ready to start again. There we go. He jumps off, and we restart again. All I need to do is maybe refine this to 5.5, compile and save, and try it one last time. Play the cinematic. Boom. Not bad at all. Well, I hope you enjoyed it. I'm doing this one more time and let it play out. I love it. I need some music for it, though. Yeah, that's perfect.
Okay. Next. Quiz. The level blueprint is a unique blueprint which is created by default and can access all instances of actors in a level. True. You can temporarily alter the pivot point of an actor in your level by holding down which hotkey combination? Alt middle mouse button. That's something we learned, actually. That's actually really cool. I didn't know you could do that. I love that you can. Saving the position of a simulated physics object during a simulation will set the position of the object only when the project is ran and is unable to change. False? Where would you access the level blueprint? I guess it's changed now. Oh, I guess blueprint dropdown. You can select all actors of a class with the Select All Actors of Class menu item from Actors Select menu. True. Complete. You passed. Okay. We did that one like super quick. Blueprint kickstart. Wait, I got the Blueprint Ninja already? Oh, because I've already completed kickstart? So Blueprint runtime saving and loading. What the hell? So becoming a BP master. This one's a little bit longer. Blueprint runtime saving and loading. Introduction.
Hello, my name is Matthew Watstein, and
Wow,
welcome
hey,
to the course
I know this
Blueprint,
guy.
Runtime Saving and Loading. In this course, we're going to go and cover the save game object system, and it allows us to save and load our data while the project's running. Included with this course is a project that you can see here on the screen that's going to help you get started quickly. Now, this project, which if you want to follow along, will include the following basic setup. We have our Blueprint Save Load folder, which contains the content that we'll be learning with, and then the Teacher's Marketplace folder, which is where these assets are contained. Inside of our Blueprint Save Load folder, we have our blueprints, classes, maps, and UMG folder. In addition to each of these primary folders, we have a finished folder.
Points.
You'll
Oh,
find
I don't know what those are
items we'll be
for.
working with, ending with _finished in this finished folder. In the event maybe you get lost or you're stuck on something, these are the finished blueprints that you can use as a reference. Any of the important blueprints you'll need that we'll be working with, like our base character and our base objects, will be found in the primary folders as we're going along. What we're going to be covering...
Oh, why? What the heck? Why did that do? Why did that do that? Oh, go back.
Quit out of our game. For example, I was to quit and then come back in. You can see that my collectibles have reloaded. In the case of our health, if I was to walk onto this platform and use my special ending option, quit and saved out, and came back in, you'll notice my health is saved in the bottom left corner. And we'll learn through these 3 different courses for these 3 different parts how we save out those different types of data at runtime in an easy and efficient manner using the Blueprint runtime saving and loading system and the save game object. The save game object is a custom object inside of Unreal Engine, and it allows us to easily store and load data, and we can run some custom Blueprint code if we'd like to. Let's go ahead and take a look at that save game object and how we might start working with it. The first thing we're going to want to do is create a save game object. So inside of our content browser, we can right-click and choose Blueprint class. Now we're going to want the save game as the parent class, so we can search for it under all classes here. And we can choose save game as the parent class. I'm going to select it, and I'll name our save game object SG_basic. And this is our save game that we're going to be working with. Let's go ahead and double-click to open it up. And
We can definitely do this at
Save game
3x.
object, save game blueprint. This is a special class that allows us to easily save and load variables that we have assigned it set up inside of it. So I can go ahead and create a new variable, and I can name this player health, for example. And if I want to save out this save game object, it's going to save out the current value that player health is set to. Now if I want to change it to something else, you can see here we have our basic types, and that's something important to note. I can change this to integer, and my player health would save out an integer. Maybe it's at 50, for example. But if I was to change it to something else, let's say for example, for character, and I want to save this out as a reference to a character I have in my level, maybe my main character, and then store all this information. It's not going to work. That's going to be an object reference. It's going to be an instant object or something that physically exists inside of our world, and it's not going to be able to save it out. We can only save out our basic types. We can't save out things like sets and maps and arrays as long as they contain those basic types. We can't save out actual instances of objects. That's important to note. Save out the data, not the actual item itself. Now, because this is a blueprint, we have the ability to work with blueprints inside of it. So for example, we can create custom events, or there are nodes specifically designed to work with blueprints. Let's take a look at some of those. If I search for save game in my blueprint menu, we can find a couple nodes here. We have the ability to create a save game using the create save game object node. After it's been created, once we're working with it and we're done, we want to save it, we can save the game slot. Or if we want to load it up, once we start our project, we have the load game slot. Now we might want to get rid of it later, we can delete the game in slot. Or we can check and see if it does save game exist. Now you notice I'm using the word slot. Slot is basically going to be the file name that stores this save game onto the local storage of your device. On iPhones and Windows, macOS, Linux, all of the different platforms, it saves it in a directory. Now there are 2 other nodes, the async load game for slot and the async save game slot. These are asynchronous nodes. That means they're not going to stop your project from running when it's saving or loading. The normal save and load game for slot nodes will. It'll basically stop processing and finish that node loading or saving, and then continue. If you don't want to see a stutter or hit when you're saving or loading, maybe a lot of data in the middle of a game, use your asynchronous versions, and we'll look at them when we get to that point. Now that we've seen the basics, let's go ahead and put some of that into use. Our
Hold
load.
on.
The normal save and load game from slot nodes will. It'll basically stop processing and finish that node, loading or saving, and then continue. If you don't want to see a stutter or a hitch when you're saving or loading, maybe you have a lot of data in the middle of a game, use your asynchronous versions, and we will look at them when we get to that point. Now that we have seen the basics, let's go ahead and put some of that into use.
Okay. Next. Oh boy.
Now that we've looked at the basics of our save game object, let's go ahead and put that information into use. We're going to save out some basic data, the player's health exactly, and load it back up when we restart our project. Right now, if we're to test, we can move our character over to this little portal to look inside, and they're going to lose health. However, when we quit the game and come back in, their health is reset to 100, and we'd rather save it whenever they quit the game. If we look at our custom character in our blueprints folder, we already have some things set up for our game. We handle our damage, and we update our UI whenever our damage is taken. We have the ability to open up our basic quit menu. So if I go and hit play and hit the U button, this is our basic quit. And when we push this, we're going to want to head and save out before we quit. So that's wired up. We also have the ability, when we begin play, to set up our user interface and update it to match our current health. So in the middle of all this, we need to go ahead and create our save game, save it out when we quit out, and load it back up when we start. So let's start by creating our save game. If you are following along and you have your SG_basic from before, let's go ahead and delete that because we're going to put it in a different place. And under classes, we're going to make our new save game. So like before, create a new save game. And we're going to name ours SG_basic again. Let's go and open it up by double clicking on it. We're just going to simply store the player's health. So we're going to create one variable of type float called player health. We're going to change this over to float. We're going to compile and save. And this is all we really need to do with our save game object. All we're using this for is to hold our player's health when we save and load from storage. Now we need to update that information whenever it's appropriate. If we go into our quit function, that's when we're going to want to save out. So let's find our quit function. In our UMG, we have the basic menu, and this is what's loaded up. And we have our quit button. Let's change this to be quit and save since we're going to quit and save now. Let's go into our graph and look at how it's set up. Our on click for the button quit simply calls quit game. So we're going to need to handle our saving of that data first. Somehow here we need to be able to get our player's health and save it out to our save game object. First thing we need to do is create our save game. So let's go and right click and create save game. And we have our create save game object node. We'll hook this up and we're going to want to create the save
Actually,
game object.
I kind of like how this one,
So
he's
SG
like
basic, our basic save game.
walking through creating it rather than the other ones where he was just kind of like
We scroll down, we can find we have the variable set player health.
showing you
inside of our save game object
an existing
we'll hook this up.
graph.
Now we need our player's health. We can go ahead and
I don't know, I just feel like
health directly from that.
this-
Let's go and do that.
this
Back
is
into our
this
site.
these like
Our custom character.
videos are probably going to be more beneficial to people who are learning this kind of stuff.
So you can see here we have the player health that is inside of our player character.
Like, don't get me wrong, there's like a couple things that that I've learned from the last few things, which weren't really
An object that
blueprints
holds our updated variable.
related.
Let's grab the save game object and we're going to save to slot. Since we're not too worried about it using up many resources since it's just one variable, we're just going to save game to slot. We'll hook this one up. So after we set the variable,
They were just
we
kind of
set this save game
editor
object.
general
Slot
things.
any name you want. It could be save, it could be doodad. I'm just going to go with slot 1. Make it easy. User index isn't really much of an issue. It's used when you're saving out on certain platforms. Just go and leave it at 0 unless you need to change it. And at this point, when it's done, it's going to return back a boolean saying if it was successful or not. We can use that if we need to maybe validate a save. And then we're going to quit the game right after. So our code right here is pretty simple. We create a new save game object. It's going to be an object in memory that has our basic default values.
Oh, see, and then he goes back and steps through what,
Set a variable inside of our
okay.
save game object to the current player's health.
This guy actually is a really good educator so far.
And then once that's done, we're quitting our game. We're going to compile and save. We'll go ahead and play. Now if we move our character over here,
Of
damage.
course, I know
Push the U key to pull up our
I
save
know
menu.
Mr.
Let's click
Wadstein.
save. We saved it out.
He's got a
Now, if we play
bunch
again,
of videos on
still
YouTube.
have the original value,
I think it's
but
pretty
we'll
cool
go
that they
here.
started working with him for this stuff. I wonder if they hired him then.
The begin play is where, well, our character begins play at. We create our user interface, we add to our viewport, and we update its health value with the player's current health. So we really want to do it before this part. So I'm going to select these nodes, drag them over just so I have some room, and we're going to do it right here. We're going to load our save game and get our variable.
He does have a kind of a slower speech though,
We
so
didn't save from slot before. Let's load from slot.
definitely need to speed up his
We have our load from slot
videos.
now. Since this is in the beginning when our project first starts up,
I
we're
should
worried
be
about
doing
this.
that in general
We give it our
more
name.
often
Our
though.
name was slot 1. And it's going to give us back a loaded game, assuming it can find it. If it
But
can't
at
find
the
it,
same
it's gonna
time, I
go
also
to
think
the
it's
game value
good that
slot
he
1.
talks a little
Now, assuming it can
slower,
find it, we're gonna play
because
player
it
health.
helps, in particular,
Well,
new
notice I don't
people
have access
who
to my player health. I did not know.
are trying to follow along
Save
and don't really know what they're doing. Having someone so I'm sure he's doing it intentionally, talking slower,
We'll go and put this in line here. Load it up.
for people to be able to follow along.
You can see inside of our SG basic, our basic save game we've loaded up from disk, we have our player health. We're just simply going to set the current player's health. So we'll drag out player health on the left
Which,
and set
again,
to that value that was saved.
it's a
Like that.
smart thing to
And
do.
then we'll go ahead and hook back up our wire that we had before. Now when it sets the health display on our user interface, it's going to grab the current player's health, which we've loaded up
You
from our
could
save
also
game.
just drag off
Start it
of
out,
that
compile,
set
save,
node.
play. Now if everything worked, you can see we have 40 health now on the bottom left. We can go ahead and go over to our platform, take a bit more damage. We'll walk off of it. We're now at 20. Now if we quit out, it's not going to save it. Remember, we have to call our save game node to save. So we'll try that again. We'll take a bit of damage. Press the U key to pull up our temporary quit and save menu. Quit and save out. We saved at 20. If we hit play now, we're at 20. So that's working exactly like we had hoped. Now one issue you may run into is what happens if we try to load and it's not there? Then we're going to get an error. This is where your is valid or your does it exist node comes into play. So let's go ahead and take this code here. Everything after our add to viewport and select it. I'm going to use the arrow key.
Oh yeah, because it's
And let's make sure it's valid.
loading.
So let's right click and do does.
But if you don't have a save there, it's gonna it'll
this up, and we'll check for it.
it'll
Again,
probably
we see
crash.
save game, slot 1.
So
And if it exists
yeah.
on our storage device, it's going to say yes, and if not, it's going to say no. We'll do an if or a branch. And if it does exist, go ahead and load your game. If it doesn't exist, well, we don't want it to do anything. We still need the rest of this stuff running. We still need the display and setting our references inside of our game mode. So let's go and hook that up.
Yeah,
Drag
you
it
just
here,
want to skip
add
that.
a reroute node, drag farther along, hook this up to our set health display, double click on our wire to add another reroute node, and while it's not the prettiest, it's back to being functionally proper. So looking at this, we now have it checking to see if our save game exists. If it does, it loads it and updates the player's health. If it doesn't, it goes ahead and skips the part for loading, because
Yep.
we can't load something that isn't there, and sets the player's health to the proper information. And that right there is the basics of saving and loading in a variable. Now if you want to
Hey,
remove the
buddy.
stored save game, you'd use the delete. So let's test that to make sure it's working, so we can actually see the second wire running.
Hi.
We'll also hook up a print to it, so we can see that it's working. We're going to update this. And we've got
Hey.
save game does not exist.
What are you doing?
So that way if it doesn't exist,
Where are you
it'll print
going?
if we hit play right now, it's not going to print that because it does exist. Let's just temporarily go over to the right. We're going to do I keyboard. You can do any key you want. I'm going to use the I key. We're simply going to delete our save game when we press the I key. So we do delete game and slot, type in our slot name. Now anytime we press the I key, it's going to delete that game. We'll play. No message. We have 20 health. We'll push the I key. Nothing happens because, well, we've deleted it and we don't have any feedback. But if we close out and now hit play again, now you can see it says save game does not exist on the top left, and we're back to 100 health.
A little bit.
Those are your
He's
three
got
basic
a
modes,
little
loading, saving,
little bit of
creating,
zoomies
as well
going
as
on
deleting if
here.
you need it. Let's look at something a little more
Just
advanced.
cat
saving and
things.
loading our options menu and its individual quirks.
Accessibility options.
An options menu is a common use for saving and loading data. Let's take a look at updating our options menu so we can save the settings and load them up as needed. Inside of our project, if we hit play, we hit the O key to open our options menu. We have a basic options menu with some accessibility options. I can change difficulty to easy and update the scale, and then hit resume. If I go back into the menu, it saved it. However, if I quit out, come back into my project and hit O for options again, they are back to the defaults. And that's because it's not saving it to disk, it's not saving it between sessions. So let's look at how we're going to do that. If we look at our options system, if we look at our menu for the options, we're basically, when we resume, we are talking to our game instance. We can see that right here. And we are sending that information over to our game instance and storing it in a variable called options. So if we go over to our game instance under classes, gi_our game. It's pretty simple. We have a game options variable, which contains a structure, which is basically a group of variables. And then whenever we call update game options, we update it with our changed options. Let's work on saving those out to disk. First thing we need is our actual save game object. We'll go back to our content browser. Under classes, we'll right click. We'll go to blueprint class. We're going to type in save at the bottom like we did before in our previous videos. So we can choose save game as our class type. Select it. We're going to name sg_options because this is the save game for our options. I'm going to go ahead and open it up. Inside of here, well, we need to save something. Since our game instance holds a structure that holds our options, it's a variable type options struct. That's what we're going to want to put into our save game. Going back to our save game, we add a new variable. We'll call this one options. And we want this to type options struct. So we'll type in options. We can find here options struct finished. I'll select this, compile and save, and you can see we have our default values. Now keep in mind the default values of the structure and the default values of our save game may be different. And whenever we create a new save game, it's going to use these values. I'm actually going to change these over to easy for the difficulty and 0.5 for the different sound volumes. That way we can make sure that they are changed. We'll compile and save. Now our save game itself is done. We're only going to use this to store our options structure. We can close that down. Now where do we want to save and load this information? We're going to put it in our game instance because our game instance is storing these actual options. So having it handle the saving and loading is a pretty simple thing to do. This is going to be done the same way we've handled saving and loading before. We're going to start with our save game event. So we'll right click, we'll type in custom event, add a custom event. We'll call this one save options. And we're going to call this whenever we want to save our options to our storage. We'll drag off the wire. We'll create a save game. Since we don't have a save game at this point and we're not storing one for later use, we need to create one whenever we want to save it out. The save game class is going to be sg_options. And from that save game class, we're going to want to update the options variable that's inside of it. Drag off return value, type in options. You can see we have get and set options. We're going to set the options that is inside of our save game. And I'll hook up the wire, so now it's going to call that. What options do we want to set? Well, we want the ones inside of our game instance. And since we're in our game instance, we can drag from the variable list, drop it, get a copy of those options inside of our game instance, and assign it to our setter. So now we are setting inside of our save game a copy of our game options in our game instance. We're good there. Now we need to save it out to a slot. Drag off the wire, type in save game, choose the save game to slot. Which object we want to save? We want to save the one we just created. We'll drag off the return value from our create save game object and plug it into save game object. Also double click a few times on the wire just to clean it up a little bit. What slot name do we want to call this? Well, we'll call this our
This
option
is
slot.
this is something
You'll
else.
notice we're creating a
Like
different save game, not like we did before. We're saving our base save
people
game.
don't really
We also
consider
create a
this,
slot.
but
So
like
this way we
I
can have
love
different
that
slots
he's
inside of our
also
storage
trying to
different things.
teach
You don't have to. All this is saving,
organization.
but for my intended purposes,
That
you
is
guys can
something
remove
that
type
you
save
are
game doesn't matter.
absolutely going to want to
Once this is
know
done, we can compile and
early
save, and that's all we
on,
need to do.
in
We'll
particular
call this,
with
create a new object, update the variable inside of that save game object, with our
blueprints,
options, save game.
because
Now we need a way to load it. So we're going to right click, event. We're going to do load options.
developing
Well,
organizational
save game, and then we
habits
want to go
with
and load it. So
blueprints,
we'll drag off,
it's
save,
only gonna
save
help
game
you.
exists.
Like
I'm going to copy our slot name from the other node, or type in options
there's
slot,
nothing.
and
It
slot.
doesn't hurt
If it doesn't
performance
show up,
in any
type in
way.
if,
It
and then
just
if, it gives a branch. If it
it
does, we want to load the save game,
saves
go off of the tree,
your
load the save game
brain
slot. What's our slot name? Well,
because it
option
is
slot. You can choose option
awful
slot,
otherwise.
slot. once it loads up our
End
options
up
block,
starting
we
to
want these
see
variables.
all of those
Remember,
nasty,
our return
like,
value here is
spaghetti
save game,
code
save game,
things.
So we have to cast this to our SG_options. So we have the correct save game that's being loaded. Assuming this loads up, we want to get the
Forbidden
options from it.
pasta.
So our saved options variable that we saved off the disk, we want to set it to the options variable that's inside of our game instance here. I'll drag off the variables from the left again. We're going to set it. We're going to hook up the options inside of our save game right here to the options inside of our local game instance. Plug it into the wire at the top. And that's all we're going to need to do for this. However, there's something important here. Remember before I had us change our save game to have a different set of options. If we were to do nothing right now, if our options didn't exist, our little save for the options, we would have the options here inside of our game instance and not the actual ones that we set up and changed. So for our false branch, we want to actually create the save game.
Yeah.
So we're going to create a save game object. This is going to give us a save game that's of the default save game settings. So select the class save game options. From the return value, because it's a type save game, we can just simply get the options out of it. And then like we did here before, we'll drag off from the left. We'll set the game instance's version to the save game's version. And now whenever this is called, you assume probably when we load the project, whenever we load the options, we're now either going to have the options that we've adjusted, that we have saved before, or the default version. So let's go ahead and actually check that out and make sure it works. But we need somewhere to actually, well, save and load our options. And that's back inside of our user interface. It's also inside of our game mode. So
Save.
let's close down our game instance. In our classes folder, we're going to go to our GM_our game. This is our game mode. And right now, all we're doing when it starts up is we're waiting a little bit. We're mimicking a load screen, basically, and updating the user interface for our collectibles. We also now want it to load up the options that we have saved. We have our code in our game instance. The nice thing about game instances is almost anything can get them. So we'll right-click. We'll do get game instance. And here you can see the game instance can be gotten. We need to make sure it's our specific one. So we're going to cast it to GI_our game. So it's our version of our game instance, which has our custom code. And then from the as GI our game node, we're going to go ahead and run the load options function. And this will load up our options off of the disk or create a new save game with our customized options. Okay.
Oh, okay.
But we have no way of testing it until we
And
actually
play.
save it. So somewhere we need our interface to save these options out.
Wonder if the
So go back to
delay
the
is to
browser.
just.
Let's go into our UMG folder. Go into our UMG_options menu.
It's kind of.
Once it's loaded,
I've
go
seen a
graph on the
few
top right.
people like
And on the top, we can see our event graph. This is our
add
primary
delays
spot
to
where we're
things. I don't really
click
understand
resume.
why.
That's when we're going to want it to be saved, once we've left our menu. So in here, we can look through our code. And the last two parts are setting our input back to the game and removing
Sometimes it
options
feels a little
So right before that,
arbitrary.
let's go ahead and
Like
close off this side
they'll
a little
put
bit.
in a delay and be
We'll
like
go route node off the side.
0.2.
We want to talk to our game instance and ask it to save our
Seems kind of.
like before.
I guess
Game instance.
it is really
After we have
slow
our
when
game
you
instance, we're
consider
gonna pass it to our
computer
game instance, our game.
um,
We'll go ahead and hook it up so that way we make sure it runs our cast.
processing time.
Inside of our game instance, we have our save options function. So dragging off of our game instance, our game, we can save the options. Once that's done, we'll go ahead and finish closing out our menu. So at this point, inside of our user interface, we can save our options. Inside of our game mode, we can.
You know,
load
I've
options.
never actually
Check it out.
seen anyone
Remember
do
that?
anything on
We'll hit
cast failed.
We'll hit O for our options menu. Now you might notice something different. Our difficulty is easy, and our sound and music are now in the middle. And that's not the same as we had before. This is because we're using those values inside of our save game that we adjusted. We'll adjust our scale, let's say all the way to the top, our difficulty up to epic, and we'll resume our game. If we go back into our options, we should see them change. That's what we expect. It did save them whenever we were inside the project. It was just when we quit that it did. So I'll quit out now. I'll hit play to go back into our project, and we'll hit O, and if everything worked right, now our options menu is larger, since our scale is up to the top, and our difficulty is epic, because we're loading our save game like we had planned on. At
Hooray!
this point in time, our options menu is now working fully and saving and persisting between each session. And that is the basics of saving out and loading something a little more complex. We're using a structure, which is a bunch of variables in one variable, and we're easily saving and loading them out without any issues.
Oh, we have a quiz. Okay, save game object can only be used to store variables. Any nodes in the save game object event graph will not work. Save games. False. If you want to save your game object to storage, which node can you use? Save your save game object to storage? Save game to slot. You can store more advanced variables such as enumerations and structures inside of a save object. Yeah. Oh god, I almost went with false. You are trying to make a new save game object for the first time to store variables. Which node would you use? Wait. Create save game object? Is it new for the first? Yeah. Okay, create. You can only use a file explorer to delete your save games from the storage device. False. Complete. Well, that was easy. Setting up our objects.
One common use for saving and loading is keeping track of changes in our project as time goes on. In this example, we'll be keeping track of a few collectibles in our world. And then when we load the project back up, we'll go and remove those items since we've already collected them. Running through our project, if I go and hit play, we have a few collectibles you can see just spinning around the world. Once we collect enough of these, the main door will open. So we've got 2 of them collected. We can see on the bottom right we have 1 left. We collect the 3rd one. Our door opens up, and we could go in, and then we could finish by collecting our relic. Now, let's say this was a larger project, and this took me 20 minutes, and then I want to come back later to play. All of my items would be reset, and that's not really something we want the user to experience. Now, these objects exist in our world. These are instances of actors, so they have unique properties to them, but we can't save out actual actors. We couldn't say, for example, okay, I collected this item. Let's save out all of its information, and then when we load the game back up, we can load its information back up. We can't do that. We need some other way of identifying these items to work with them later. And one easy way, because remember, we're dealing with raw data, raw variable information, basic types, is to create a unique ID. If you've ever played like an online game or ever done something maybe in a spreadsheet, you have unique IDs. We could go in and we could take our blueprint. So I'm going to go to our blueprint folder and go to my pickup.
Okay, this is going to actually be really interesting.
Call it ID. I'm going to change it to type string, compile and save, and then I could type 1 or 2 or A75 or coin 1, coin 2, coin 3. But what if I add more coins later and I forget where I'm at? Well, then I have to go and find it. Or we could try to make something that's automated, and that's what we're going to do. We're going to take advantage of our construction script. So on the left we have construction script. I'll double click open it up. This is something that runs when the item is constructed or when we're working in the editor and we move around. Generally only fired once. And the nice thing is we can use this to generate unique identifiers. If we right click and we type in GUID, we have the ability to work with GUIDs. And these are basically unique identifiers that are long enough where they're really not going to conflict. You could generate them over and over and over and almost basically impossible to conflict. So if we generate a new GUID right here and we save this out, we can make sure we have a unique identifier for every single item. And all we have to do is add a new coin to the level, the construction script runs, and we'll get a new ID. But this ID is a type ID, and we want to make it easier, so we're going to make it a string. And we're going to store it in our ID, as we can see here. We'll drag off ID, we'll set it, and all we have to do is drag off of our new ID return value, and it won't be compatible string, so we can actually type in string, and you'll see toString GUID. And now we can connect it. And now whenever we run the construction script, we're going to get this to run, and we'll get a new GUID.
Oh,
But we want them
hey.
to be unique, and we don't need them to keep changing, because if they kept changing, then every time we load our project, we end up with a new ID. So we're only going to want to set the ID if it's not set. Simple as that. So we're going to go ahead and grab our ID from our left and get it, and then we're going to type in equal. So is it equal to nothing? Drag off return value, type in if. We're going to pull out a branch. We're going to hook our construction
If it's
script up
equal to
with branch.
nothing,
So if our ID is equal to nothing, then we want to
set it.
create a new ID. Hook up the true from our branch to our set, and now our construction script is set up. Now I can go ahead and click the eyeball here on the left to make it public, so that way we can examine this actually working. Compile and save again. Go back into our map, and we'll click on one of our pickups. And you can see right here we have an ID.
Oh,
If I
hey,
slide it
that's
around,
cool.
That ID is not changing. We can actually
I
reset
didn't
it.
actually know
It's
about
different
this
IDs, so
one.
you can see how long and unique this is if it conflicts. We're in trouble being
That's
set up
cool.
with a new ID. We have our nice unique ID, and if I was to, for example, take a new blueprint and drop it into our world, it's got its own unique ID, and then we don't have to worry about conflicts, and we don't have to worry about assigning these by hand. So now that we have our unique ID, we need some way to talk to these pickups, and we need some way to get the identifier, and we need some way to tell this pickup, okay, you've already been picked up, so do something. In our case, we're going to destroy the actor, which will basically act like it was picked up because we've already picked up. One easy way to handle something like this is by using blueprint interfaces. Now we could hard code that information, but what if our pickup was more than just coins? What if it was some other item? Maybe it was food or treasure chests we interacted with, or doors we opened up. This gives us the ability to generically change the state of an item at runtime. Let's go into our classes. We're going to right click. We're going to go to blueprint interface. I'm going to name this BPI underscore, and we'll call this interactable. This will be our interface that will be on any item we want to interact with, and we'll have our interaction events. We'll open it up by double clicking. I'll go and dock it at the top to make it easier. It comes with one function by default, so we're going to actually have 2 of these. One of them is going to be to get the identifier from the object, so we'll simply call this one get ID. So that way when we talk to our items generically, we can say, hey, what's your ID number, and then compare that to our stored list. So that means it's going to have to give us that information. So on the bottom right under outputs, we're going to go new parameter. For the name, we're going to call this one the ID, and it's going to be of type string. We'll compile and save, and this one's done. And then the other one is just our generic, hey, you've already been messed with, we've already picked you up, we've already opened you, we've already collected your loot, we've already stepped on you. It's the ability to generically change our state. So on the top right, we'll add a new function, and we'll call this one simply change state. And all this is going to allow us to do is we're going to call it and change the state on the item. Compile and save, our interface is now done. Inside of our pickup, now we need some way to actually work with these interfaces. Blueprint interfaces are set up under class settings. And then on the right in our details panel, we have the implemented interfaces. We'll click add. Here is our blueprint interface interactable. We'll go ahead and compile and save. And here's something that's nice.
This
We
is
want
kind
to
of
create
impressive.
dynamic
I
interfaces. We
didn't
already have
expect
any of those
them
interfaces
to
set up,
actually
interface ready to work with.
walk
So we're going to
anyone
want to change
through
state and get ID.
creating
Double click on any of these. Well, you guys know how
interfaces.
it works for change state because it's a new
Interfaces are
interface.
amazing, by the
Go ahead
way.
and set it up. But get ID is a function.
Like recently discovered
Now
them.
it's asking us to return our ID. That's simple enough. We'll
I
drag
guess
our
I
ID out of our
shouldn't.
variable
I don't know.
list,
I
type
mean,
on
it's,
the
I still
and now whenever
feel
we
like
load it,
it's
well, our
recent,
ID is
but
going to be returned to us. Okay, that's easy enough. What about changing the state? Well, we can right click on it and we have implement.
you
event.
can do
We'll go
some
click on
all
that, and now we
kinds
have
of
our
cool
event change state.
stuff.
The nice thing is this is generic. We can call this on different items, and each item can implement it however they want. In our case, the state that gets changed on this item is the collectible gets destroyed. Whenever we overlap the player, we destroy the item. When the item is destroyed, we tell the game mode it's been collected. So all we have to do is drag off, type in destroy actor. You'll notice destroy actor is again what we use up here when we overlap it with the player. And that's all we need to do. Whenever we want to interact with this item, whenever we want to change its state after we are loading up from a save game, we'll call event change state, and it's going to destroy the actor. Now this was setting up our one object. This is the same basic process if you want to set up multiple objects. We would just implement our interface, implement getting our ID, and changing the state, and we'd be done, and they'd be easy enough to all be interacted with generically. So let's look at actually saving out our unique information and then loading it back up.
It'd be cool if
Now
I
that our
could
object is set
save
up
my
locally using our GUID, and
video
they can tell when we
playback
want to
rate.
change their state. when we load our project, we can go ahead and finish setting up the process of saving and loading. Well, like before, first thing we need to do is actually create a save game object so we can save. We're going to go to our class folder in our content browser, right-click, blueprint class. Under all classes, we're going to search for save game. Select it. This one will name save game underscore collectible because we're going to store our collectible information in here. Once again, we could make one giant save game, but we're going to make individual ones just to keep things, well, we'll say loading faster, but it makes it easier for organization purposes as well. We'll open up our save game. Now, what do we want to save out? We need to save our identifiers. So we're going to make an array of strings. So it's basically a bunch of strings. And every time we pick up something, we're going to update that array with the new identifier so we can then work with it later. We'll go to variables, new variable, and we'll call this collected items. We'll make it easy. We're going to change it to a string, compile and save. Now we can change this to an array by going to our variable type in the details panel, drop down and choose array, or inside your variable panels in your detail tab, you can go ahead and right click and this will change it to an array. Either way, we need an array and we have nothing collected yet. We're also going to make another variable and we're going to call this one slot name. Now we don't want this one to be an array, so let's go and change this back. We'll click on the type over here, change it back to a single variable, compile and save. And let's change our slot name to the actual name of this slot. So we'll call this collectible slot. Compile and save again. Our save game for now is done. But we need
So you see, he's creating a separate save game object to handle the collectibles.
And our code in here is once we begin, we load up things like our collectible user interface and our options.
I suppose it
whenever we have a collectible and we increment
makes sense.
It's called when we collect them. Somewhere in here, we need to keep track of our save game. Now, rather than loading and saving our save game once, we are going to save our game every single time we pick up a collectible. So rather than creating a save game, updating it, saving it, and destroying it every single time we collect something, we're going to just store our save game object inside of our game mode so we can easily reference it. Now let's go ahead and create a new variable. We're going to call this one sgref, save game reference. We want it to be of the type that we created. So we'll type in collectible, and we'll look through our list and try to find it. Here we go. SG collectible. We want the object reference. We'll compile and save it. And now we have a way of keeping track of that save game once we've created it. But, well, we need to actually create it. So how do we do that? Well, normally it's on the loading and the saving event. So let's create our save event because that one's a lot shorter. We'll find an empty spot, right-click. We'll go ahead and do a custom event. We'll do save game. Now, we probably shouldn't call it save game because we're not actually saving the game. We're kind of saving the collectibles. So we'll go and rename this, and we'll name it to save collectibles. And you notice collectible is a longer word, and maybe you misspelled it. Maybe you spelled it with one L or an A instead of an I. And this is one reason why we put the slot name actually inside of our save game. But you might be asking, well, how do we get it if we don't have one that exists? And there's a nice function called get class defaults.
What?
So we right-click and we type in get class defaults. We can find get class defaults. It's going to ask us for a class. In this case, it's going to be our save game collectible. So I'm typing SG for our search, save game collectible. And it's going to give us, well, the variables we created inside of there, and one of them is our slot name. So now when we save our collectibles, keep in mind we're not going to need to create our save game anymore. It's already going to exist. We're just going to need to save this out to a slot. So we'll drag off our save collectibles. We'll do save game to slot, and we can plug in our slot name. And then we can take our slot game, our save game reference right here, drop it on our save game object, and it's done. However, every time this is called, it's going to stop the game, save everything out to the drive or your storage device, and then
okay, I never really thought about using the get class defaults.
Let's delete our save game to slot, drag off our save collectibles again, type in save game, and we're going to want our async save game to slot. So this is going to use some custom code in the background to try to save without screwing up the rest of the project while it's running. We'll hook up our save game object again, and our slot name, and now we're
yeah, async.
The biggest difference is you can see here, if you have a completed node, so maybe we want to start saving, update the user interface with a little save icon. Once it finishes saving, update the user interface and remove the save icon. And you can do that all from here.
Yeah.
But this is the basics of saving out our collectibles. Let's create our load collectibles custom event. We'll type in custom event again. We'll type in load collectibles. And the nice thing is at this point, if you follow the other courses, you should know which functions and how we want to do this. So we want to, does save game exist? Oh, look, we need a slot name. Let's make sure we spell it right. Or we're going to grab our class defaults node. I'm going to right click and copy it. And then right click and paste. Oh, I can't right click and paste. Control V to paste. Or just make get class defaults again. Anyways, we want that node. Plug that into your slot name. Now we make sure we're going to get the correct slot name for our collectible save. If it exists, we're going to do an if.
It's actually real smart, yeah.
Same thing we did before.
You don't have to worry about making sure you typed it in right.
Other options. We want to load if it exists.
And you don't have to create a variable.
We'll load save game. Now, we're only going to be loading up when the game starts. We don't really need asynchronous load. It's not going to be run during gameplay. We can use the normal load game. Again, grab our class defaults. We're going to go ahead and duplicate this time. So you don't have Control C and Control V. Drag it over here.
You can just do Control W for that duplicate.
Cast this to the correct one. Cast it to our SG underscore collectible. Now we have our collectible save game. As our collectible save game, we're going to drag off the variable list from the left, drop it in and set it, hook up our execute wire, hook up our return value, so that way we are saving this locally. And now we have a save game that we can mess with. Okay, we're good there for loading. We need to create a new window. We need to make sure this is a valid save game at all times, because we're going to be writing to it. So under false, create save game. What type of save game do we want to be? Save game collectible. The return value we're going to set like we did up here. So drag and drop and set. Connect up our two wires. And now our loading is done, and it should look almost identical to all the other loading we've done before, except now we're actually getting a slot name from our save game instead of remembering to type it in.
Huh.
We have our loading, and we have our saving. This is great. We don't actually have any items we are saving or loading. We have our little collected items variable here, but we're not doing anything with it. So we need to make sure we're actually doing something with it. When should we be doing that? Well, we should be doing that whenever we're actually interacting. So if we find our code somewhere here, here's our collectible collected. Every time it's collected, we need to update that variable inside of our save game with new information. Where should we do that? We subtract an item, we update the user interface, we check and see if everything's been destroyed, and then we open the door. So let's go ahead and put it in here maybe right about here. Update the collectible UI. Well, what are we doing? Well, once the collectible is collected, somehow we need to identify that collectible and add it to our list. How do we do that? Well, we need that ID. So whenever the collectible is collected, we need that ID to come with us. So let's find where that's called from. Let's go back into our browser. Let's go back to our blueprints. Let's find our blueprint pickup and open it up. And let's find right here, collectible collected. So inside of our game mode, we're calling collectible collected, and this is where we want to pass in our ID. Go back to our game mode. Here's our collectible collected event. If we click on it under inputs,
I was
we
gonna
can
say, yeah, you
and
just
set up
put
a
in
string.
a,
So I'm changing it from Boolean to string.
an
type in an
input
ID,
node
and now we can pass in that ID. We'll go back to our pickup, and now we have an ID spot. We can easily grab it from our variable list and drop it.
on the node,
And now whenever we
rather.
destroy our pickup, we're going to pass in our
Yeah.
unique identifier to our game mode. Okay, let's save and compile. You'll notice we get an error. Now this is a weird one. We have no idea what this means. Well, basically it's saying that the collectible collected you're trying to work with doesn't match the collectible collected that you're trying to work with. But they both look the same. If you notice, we haven't compiled our game mode.
Oh,
This is
yeah.
something to keep in mind, and maybe why you notice I pretty much compile every time I change something. The signature for this event inside of our game mode doesn't have an input. But the signature for the event we're trying to call has an ID string right here. They don't match because our signature in our game mode isn't compiled. We compile and save, we go back to our pickup and compile and save, and now we didn't do anything that mysteriously and magically works because our signatures are now matching.
Yeah, that's one
That's
of the
events,
weird,
compile,
goofy
save,
things about
let's go back.
Blueprint.
Okay, so we have our
Like,
ID. What are we going to do? Let's grab our save game.
If anyone had
Okay,
been playing
so save game
around
contains
and ran into
a
that, they
slot and it contains
might
our
have
collected
been
items.
like,
We're going to add to our collected items.
I know I ran into that
We're going to get our
once,
collected items. Collected
and I
items.
was like,
Let's go
wait,
add.
what?
Drag off of the return. Let's do add unique just to make sure. It can't hurt. I doubt we'd ever run into a
That's
conflict.
why
but
compiling is a really good habit.
and we want to add that ID that we just got. So we'll drag off of our ID input, drag it onto our add unique. We'll go and double click on the wire a little bit to make it a little more fancy like this. And now we are adding in
There is
that
again,
identifier, the
making
ID
sure you
that's
have those good
we go and hook
habits.
this other code back up.
I
So
like
after we log
that.
into our list, we go and check for collectibles being destroyed, and we open the door. And then, well, we're still not saving anything. If you remember before, I mentioned I want to save after every time we pick something up. We want to make sure we save. So off of our false, we'll drag off, we'll type in save. Now, what did we call that? That's a good question. Where did we put it? That's a better question. We called it save collectibles, and that's going to save out to disk. Go back to our code, drag off the false again, type in save collectibles, and you find save collectibles. We also want to make sure this is called even after we open the door. So we basically, anytime we do something
Okay.
here, we want to save our collectibles array. We'll compile, we'll save. Now we should have everything saving out. We don't have anything loading because we're never actually calling the load collectibles. We have everything saving out properly. What do we need to do now? Well, we need to load, and then we need to actually tell those items after we've loaded to do something. So where is our load function going to go? Well, this is in our game mode, and this is part of our collectibles in our game mode, so let's add it into our begin play. So after we update our UI, after we update our game instance and load our options, let's go ahead and load collectibles. After we've loaded our collectibles, keep in mind all our load collectibles does is give our save game either a brand new set of collectibles to keep track of, or loads up the ones we've actually saved. We need to do something with it. And that's what we create our interface for. Remember, our interface allows us to get our ID, and it allows us to change the state. So let's create some code to do that. Now that code might be a little complicated, so I can tell you right now it's going to be more than a few different things. We're going to have to find all of our objects, compare some things, go through the array, loop through it, call some code. We're going to turn it into a function. It just simply makes it easier. Anytime you get more than a couple nodes, turn it into a function, make it cleaner. We'll go to functions, new function, and we'll do check for collectible changes. Because, I don't know, it's a long name and it sounds good. So we're going to call check for collectible changes. Let's go ahead and do that now before I forget. Let's go to event graph. After we load them, we're going to check for collectible changes. We can drag off and drop, and now we'll call that. That way we don't forget later. We're like, oh, why didn't it load up? Well, because we've got to check. So now we're going to load, and then we're going to check. Double click to check again. What's the check going to do? We have our unique IDs, and we have an interface on all of our items with unique IDs. So we can look for all the items with the interfaces and talk to them if they're in our list. Simple as that. Drag off our check, get all actors with interface. This is going to give us an array of everything that has an interface.
Oh.
See, we have an interface called BPI_interactable. Everything that's interactable with, we want to actually see if it's inside of our saved array. So we're going to loop through each of these. So we're going to for loop for each loop, hook it up to our execute. At every single item with an interface, we're going to say, hey, are you inside of our list? Do you have the matching ID? If so, we've already collected you. Go ahead and do whatever you need to do. We've already stepped on you. Go ahead and do whatever you do. Whatever you want. You've interacted
Okay,
with you before,
yep.
You're on our interacted list. Finish, do your interaction again. Well, how do we do that? Well, we've gone ahead. We've looped through them. We want to get the ID from here and compare it to our list. Well, guess what? We can drag off the array element, type get ID, and look, under BPI interactable, we have a get ID because we created that generic interface to generically talk to a generic item and ask it for its ID if it has one. So now that we have the ID on the item we're talking to, so let's say we have 4 coins in the level, we're talking to the first coin, we've got its ID, what do we want to do with it? Well, we need to see if it matches our saved IDs. We'll grab our reference to our save game. Remember before I mentioned we're going to be working with this a lot, so that's why we're keeping the save game inside of our game mode. And we're going to type in, well, not contains yet, get, now scroll down, get our collected items variable. So now we have an array of collected items, drag off the array and type contains. Does it contain an item? Well, what item are we checking to see if it contains? Well, does it contain the ID of the item we're talking to right now? Drag off the return value, type in if, branch, connect it to execute wires, and now basically we're going to talk to every single item and ask it if the item's ID exists inside of the items we've already collected. And if it does, do something. If not, well, do nothing. We don't care. Well, what do we want to do? Well, we created another Blueprint interface event called change state, so call change state. A message, change state. Who do we want to tell to change state? The item we're looping through right here. So we'll just drag up off of our array element, connect it, do a little bit more fancy Blueprint wire work like that. And that should be the basics of our code, and I'll compile and save. So, hey,
These are the
keep track.
cleanest
If you can't,
blueprints I've
Sterzy,
ever seen.
does that ID exist in our saved list of IDs of collected items? Yes or no?
I
Yes,
lo-
we'll go ahead and change
like,
it to what we looked before.
I
We can
actually
combine
love
yes
it.
because it's habit. In theory, a lot of this stuff looks like it's good. Is it good? Well, let's find out. We'll go to our map. We'll hit play. We have 3 on the bottom right. We have collected nothing. We'll collect an item. We will hit escape to stop. We'll hit play again. We have 2. That item that was here is gone. We can go back over
Hey,
here. We'll collect that item. We can continue walking. We can collect the last item. After we collect the last item, we have none.
that's
The
pretty
inventory is open.
cool.
We can quit out. We can wait a second or two just to show there's not stuff in memory. We'll hit play again. You notice the bottom right says 0, and our door's open.
Nice. Next, our conclusion.
We took a look at how the save game object works, and the ways we can use it to expand on what we can do with our projects. Now, there are additional resources available to us as well, and there's more ways to take advantage of the systems, so let's just take a quick look back at what we've done and some future things to consider. We've taken our project, and we've added the ability to save out the player's health. We have the ability to save out the options, so if we load up our options, it will
It's
save
weird
them.
because
We also have the ability
1.5
to save out our collectibles,
sounds like a
and
more
store them
natural
after we've collected
speech.
them. Now, in addition to this, if we go to the documentation pages for Unreal Engine,
I guess
we
it
can
is a
search
little
for
fast.
save game in the search documentation.
Only a
and
little
here
bit, though.
under interactive experiences, saving and loading your game. We have a blueprint example, which goes into nice detail, basically what we've covered, and a few other tips and tricks, as well as a fully implementable C++ example.
Does he slow down
using
his
synchronous,
videos?
asynchronous loading, as well as binary loading.
Oh, hey.
In addition to this, inside of actors, inside of our world, we'll load up our custom character. We can look at our player health that we saved out in our save game object. Under the advanced options, which we can see here on the right, is a save game property. Now, this allows us to use the farchiver if we're using C++. This is not available to us if we're using blueprints only. And we can basically serialize or deserialize variables on loading or unloading. And this allows us to more easily implement a more robust saving and loading system. And there is documentation on that on the Unreal Engine Answer Hub. And with that, I hope you've enjoyed our course on blueprint, runtime, saving, and loading.
Okay. Well, let's take our quiz here. When loading game data from storage, which node can we use? Load game from slot. When creating a save game object, we can only create them inside of our game mode or character. False. When using the save game object, you do not have to save the individual properties, but can save the entire instanced actor and load it later. When using the save game object, you do not have to save the individual properties. Wait, what did I click? Shit. Okay, you need to save a large amount of data in save game without interrupting the player experience. Which node would you use to achieve this? Async. False. Complete. Continue. Okay. Well, that one's done. And the last one is blueprints and gameplay for game designers, which is this one right here. Start course. Or not. Oh, there it is. Oh, this is a long one. Is this Matthew again?
Welcome to the Blueprints
Nope.
and Gameplay and Development course, a beginner course for aspiring gameplay designers looking to create content inside of Unreal Engine 4. Before we start, I'd like to introduce myself. My name is Tim van Kan, and I want to help you become a technical gameplay designer like myself. I've worked with Unreal Engine 4 daily since the day it became free. I'm a publisher on the Unreal Engine Marketplace and an indie developer working on different titles, the main one being Aaron's Adventure. Over the years, I've worked on a variety of projects, reaching from games or VR experiences all the way to commercials for TV. They also take
Matthew
about all the way to
Wattstein's
inside Unreal. Just because you're working in a game engine doesn't mean you're always going to be working on game experiences.
Voice definitely lends to the 2x speed a lot better.
First, we will discuss what the role
It's
is
a lot
of
easier to
designing
understand what he's saying.
We'll change variables at runtime, and we will debug our work. We will set up gameplay input for new character actions. We will create our own door parent blueprint and set up different child blueprints that share some of the functionality with its parents. We'll be adding basic sounds and particles, and we will utilize the post-process effects to radically change the look of our scenes. You'll learn how to use timelines, and you'll get an introduction to UMG. In the first lesson, we will have a look at what is expected of a gameplay designer in a team, and more specifically, a team working with Unreal Engine 4. Remember that Unreal Academy has the option to change the playback speed of the video, so in case things are going a little bit too fast for you, you can slow it down. But if something sounds familiar, you can also speed it up, and I recommend doing this instead of skipping a video. There could always be something there for you to learn that you would otherwise miss.
Next. How long are these videos going to be? Well, this one's like, what is a gameplay designer?
First up, we'll briefly talk about what it means to be
I'm just going to place like some of these things like in 3x even.
You should be able to produce concepts and gameplay items systems, look for areas of improvement to your design. You should be able to author and maintain design documents, be able to work collaboratively in a team, and be able to make quick iterations. Blueprints are the perfect tool to help you produce new prototypes for gameplay or to iterate on something that programmers already made. The uniform and consistent look of Unreal Engine also make it easier to step outside your area of expertise and have a look at other work, be able to understand what an artist is doing. As a gameplay designer, you should have basic knowledge on most of the different features of Unreal. You should be comfortable with the mesh viewer, materials, sounds, and other features the engine has to offer. Knowing a bit about these other features will make it a lot easier to work together with other departments. So, in summary, the responsibilities inside the engine are having a basic understanding of most features of the engine, knowing how to quickly iterate on gameplay elements, and being able to create new variations or completely new prototype vectors for your project. We've now briefly discussed what it means to be a gameplay designer in UE4. Next up, we'll jump into the engine and have a look at our first-person project.
Well, first person player. Oh my god, dude. What are we?
In this module, we will have our first look at a blueprint, the first-person player character blueprint. What logic is already in there, and how can we start to change those values up a bit? You can download the project from the course page, or create a new first-person character template with starter content. I'm currently using Unreal Engine 4.25. But before going into the editor, we'll have a look at the most common variables. First, we have the boolean, which is almost always colored red, which will make it easy for you to spot. A boolean can only have two values, either it's true or it's false. Example would be a variable called can sprint. It could be true, or it could be false. You can either sprint or you can't. Next, we have an integer. This is a whole number, usually colored a more dark green bluish. This can't have any decimal values, and it's not a variable that will come across a lot during the course. Next up, we have a float, usually recognizable by a light green color. This is also a number variable, but a float can have a decimal.
Wow, this is like some super basic level stuff.
By its yellow color. This is a set of three numbers which can be used for a lot of different things. Vectors are also used to indicate actors' position in the world, where X, Y, and Z all represent a dimension in the game world. If you'd like to get a better understanding of more common variables, you can check out the official Unreal Engine documentation. We will now have a look to see if we can recognize some of these variables in our first-person character blueprint. Alright, we're finally in the engine. We're in the gameplay designer project, which is basically a first-person template, just cleaned up a little bit and changed around just a little bit. We can press play, we can walk around, we can jump. These light blue cubes can actually move when we shoot at them, so you can shoot with the left mouse button. As you can see, it moves. And I'm going to press escape so we can have a look at how this is all set up. Let's look for our first-person character blueprint inside the content browser. Logically, we'll go to blueprints and then first-person template, and then we can find it. Another way to do this is to select the asset that you want to go to, select it in the world outliner or in the viewport, and press Ctrl B. It will actually take you directly to the asset in the content browser. Right now, this isn't really necessary for us, but as your project gets bigger and there's a lot of different actors.
Holy crap, that loads fast as hell when all you're doing is blueprints and like you're not using like ray tracing or anything. That was like near instant. That's disgusting.
And we have spawn projectile, which shoots that yellow ball when we press left mouse button and plays a sound. If we go to our viewport, we can see what makes up our first-person player character.
Okay.
Capsule, the mesh.
3x speed. Let's go. Let's get done with this.
Because we added the mesh directly under the camera. And another thing that we can see over here is called character movement component. This is the component that you can see, but it is a component that has a lot of movement logic inside of it. So when we say jump, it actually calls a function inside this component. If we check out the details panel with the character movement selected, we can see a whole lot of different variables that influence our character movements. We can see gravity scale, max acceleration, braking friction factor. Now you'll be able to recognize some of these variable types by what we discussed earlier. You can see that these are all floats, they have a decimal number. A little bit further down, you can see some true-false statements. These are all booleans. Alright, let's actually start changing some of these values. Let's take our maximum walk speed. Let's put it on 1,000. But we also want to change how high our character can jump. Scroll down, we'll see character movement jumping, falling, and we can change the jump speed velocity to something like 1,000 as well. We have to click compile and save, make sure all the code is compiled, and then we can press play. And now when we walk a lot faster. And when we jump a whole lot higher. That's how easy it is to change some of the movement variables around. You can also do this directly in a level. So by selecting a first-person player character, and then in the details panel, you can actually extend this a bit. When we scroll down, we'll see our character movement. With the character movement component selected, we can now tweak the same variables as we were able to tweak before. Keep in mind, this does not save it to the blueprint, so we set this to 200. Press play. We're now walking super slowly, but we can still jump incredibly high. Now, we just had our first look at our character blueprint, and we changed the maximum movement speed and jump height. And now I encourage you to have a look yourself and see if you understand what a lot of variables in the character movement components do and what the logic in the event graph does. In the next part, we'll change the maximum movement speed with a new variable that we'll create ourselves, and we'll make sure that it happens on the gameplay. In this module, we will make it easier to play around with the movement variables we have changed before. We will create our own new variables, and we will initialize them when the game begins. We will comment our code, and we will make sure that they are editable so that we can change them in the level instance as well. In this module, our goal is to override the maximum walk speed and jump height with our own new variables. Let's go into the first-person player character. Let's go up a bit. So we want to replace variables that are part of the character movement component. We can actually drag this out into our event graph, and this will create a reference. This reference will allow us to set or get variables from the component. So if we drag off and we look for max walk speed, we can see that we get a get max walk speed or set max walk speed. We'll want to do set max walk speed. This will now override the value of this variable in the component. We want to do the same for the jumping height. So we'll look for set jump c velocity and override that as well. We want that to happen after we've overwritten the max walk speed. What's happening now is that we're setting both of them to 0 in this piece of logic. We're going to create our own variables. I'm going to show two ways of doing this. First way is to go to the My Blueprints tab, and then variables, and then click the plus here on the variable. We now added a new variable. So let's call it fb underscore max walk speed. fb standing for first person. Press enter, Now if we check out the details panel, we can see that the variable type is actually a boolean. We need this to be a float. So we can click it, and there, float. If we want to set a default value, we need to compile first. So we need to compile our code. Let's go ahead and do that. Compile. I always like to save afterwards as well, just to make sure. And now we can set a default value. Let's put that to 500. Compile and save. In this case, there's another way to create a new variable. We're setting the jump speed velocity. We can go to that node and right mouse button on the green pin here and say promote to a variable. It now created a new variable, but it also sets the variable type automatically, which is nice. We'll call this fb underscore max jump height. Now we need to compile and make sure to set a default value. Let's also do 500. Drag this down a little bit, make it a bit more readable. As you can see, we're still setting our max walk speed to 0. So we need to grab our new variable and connect it. So we can drag it out here and then select get. What you can also do if you want to get a get node is hold control while dragging out the variable, and it will automatically do a get instead of asking.
Okay.
If you hold alt while dragging out, it will automatically do a set. We don't need it right now, so I'm going to go ahead and delete this. We want to connect the max walk speed to the max walk speed, and there we go. We're now overriding our maximum walk speed and our jump velocity with our own new variables. But these two nodes are just hovering in the event graph. There's nothing here that's making this happen. But these two variables at the moment are never really called. They're just hovering in the event graph. We want them to happen as soon as the game starts. There's actually an event graph you can always call in any Blueprint actor. It's called begin play. So
This feels like way more basic level than
and there we go. As soon as our game starts, we override the maximum
the
walk speed
last
and
one we
override our
did.
velocity with our auto variable. Now we want to comment this code in case another team member wants to look over it, or we come back later and want to make some changes. Let's select everything and press C for comments. And let's call this begin play.
The save game one, that actually feels like
Now, I like to do begin play. Let's go into
a
begin play.
more advanced topic.
Having begin play always be good, makes it really easy for me to find it. Right now, if we zoom out, it won't be hard to find begin play. But I don't really like reading, I like to go by color coding. So right now, I will be able to immediately spot begin play without having to click select. So we'll go ahead and compile and save, and we'll go back to our map. When we select our first person character, however, we will not have access yet to those variables that we just created. We can't change them in the level instance of our actor. So we'll go right back to the first person character. And we need to make some changes over here. If we go to my blueprints tab and we look at our new variables, you can see this icon behind it. And it says variables not public and will not be editable on an instance of this blueprint. So what we need to do to change this is just click it. And this will open the icon. This means that it is now public and that we can edit it on an instance of the blueprint. Another way to do this is to click the variable that you want to make editable, and then in the details panel select instance editable. Compile and save. You'll see that the icon has changed here as well. Go back to our first person map, and with your first person selected, in the details panel, you can now change those values. So now it's a whole lot easier for you to play, change the values, play again, change the values, play again. Something important to keep in mind is that if you do change the values, let's say we'll do 400, 400, you'll see these yellow arrows appear next to it. If we click these, it will reset back to default, which is 500. We'll change to 400 again. So this means that the changes that we make are only applied to the instance that we currently have selected. What this means is if I drag in a new first person character, the values will have reset again. So values that you set on the level instance are not saved to the blueprint. You could look at those values and go back into your first person character blueprint and then change the default value to a new value, but you can also select your first person character and then in the details panel, click on edit blueprint and then select apply instance changes to blueprint. Let's go ahead and do it right now. Apply instance changes to blueprint. We updated the blueprint. And now we can see 400 and 400 are the new normal. There's no yellow arrows. And if we go into the blueprint, we can see jump height is 400, max speed is 400. The variables inside the first person play character have updated. You now know how to create a new variable that can be tweaked in the level instance. Next up, we'll have a look at changing our variable while we play.
Okay. Okay, so there's a bunch, but these are
In
like
this module, we will add debug controls that will allow us to change
only
our
like
variables
5-minute
while we
videos.
play. This will allow us to test a lot of different values for them. We will also need to communicate these values back to ourselves so we know what the current value is. When looking at our first person character, we can see that we already have some inputs out. Move forward, move right, jump. These all have associated keys with them. For our debug controls, we don't need something so official. I just want our movement speed to go up when we scroll the mouse wheel up, and I want our movement speed to go down when we scroll the mouse wheel down. We can set up event spread directly in here. So right mouse button and look for mouse wheel up. And we'll do the same for mouse wheel down. Let's reposition these a little bit, move them up, zoom in. When we look at them, we can see press and release. In this case, that means scrolling or not scrolling. The next part we know how to do. We can grab our character movement component and we'll set the maximum walk speed. I can copy paste this, but I need to make sure to hook up the character movement components. Make this go into pressed, make this go into pressed. So line them up. What will happen right now is when we scroll up or down is that we'll set the maximum walk speed to 0. We want to change the current value. So in order to change the current value, we need to do get maximum walk speed. Now that we have maximum walk speed, we need to change it somehow. You can drag off of this and look for plus, and you'll get float plus float. Press enter, smooth these out a little bit. We'll do the same thing again. We'll look for minus, float minus float. Position these and move this down. As you can see, it can get a little bit messy. So let's clean it up a little bit. You can double click on a wire to create a reroute node. So I'm going to do that twice. I'm going to connect this to this one as well. This already looks a lot better. I'm going to move this back. Now we have a plus float and a minus float. Let's change this value to 100. But this is a very big number. Every time we scroll up, it will increase the movement speed with 100. And when we scroll down,
Well,
we'll do up.
I'm glad he cleaned that up because
Let's press
I was starting to feel a little
the
disoriented.
movement speed is increasing by a lot. Now this will probably not help you find the right value for your movement speed, but it could be fun. Something else you might notice is that it's hard to count the amount of times you move your mouse wheel up, so you really have no clue what the current speed is, so you have no idea what to change it to. And we can feed back that information to ourselves using a bunch of different methods, but the easiest one would be a print string. Let's go behind the maximum walk speed. Let's look for print string. We'll connect the two. And right now the print string says hello. You can connect the float right into the print string, and it will convert the float to
So-
text, and it will print it back to us. I'm going to click the down arrow. I'm going to change the duration to 10.
He said to do the like
Save. Now go to
you
the
can
print string. Wrap it up, connect the two,
use this as a way to find
and we walk around, we change
the
movement
right
speed,
move
so
speed.
maximum walk speed is shown to us. That's probably smart to make these values really small.
Actually, not a bad idea, not gonna lie.
What I like to do here, similar to the gameplay, is comment everything, debug, and then describe the debug. The comment I like to give it is ready. This really makes it jump out. So that if you come back later, you open your blueprint, you're reminded that, oh yeah, I had debug in here, so you don't ship with the debug still enabled to have your player able to change the maximum walk speed with the scroll wheel. We just had a look at adding debug controls and using these controls to change our variables while we play. Before going to the next video, maybe have a look if you can debug some other variables while tweaking them. Get your character feeling just right. In the next module, we'll add sprinting.
I don't know that that really counts as a debug, but start. Okay. You want to change one of your variables at runtime using debug controls. How do you build this functionality? Add an input event to the blueprint to update the variable when it is pressed. Seems legit to me. You created a new variable that you want to tweak in the level instance of your actor. What do you need to make sure to do? What? A new variable that you want to tweak in the level instance of your actor. Oh, Publicly editable. Compile. You should always compile it. Yeah, I mean, you're gonna need to compile and save anyway. Set a default value. Click edit blueprints in the level instance. Okay. Publicly editable. What is expected of you as a gameplay designer? To be a blueprint expert, to be comfortable with the different tools of the engine and know how to communicate with other design. I'd say communicate with the rest of the team. Yeah, you don't need to be an expert. You just need to be comfortable and be able to communicate with everyone, not just other designers. That was the trick question there, or trick answer. You want to create a variable that keeps track of the bullets left in a player's rifle. Which variable type makes the most sense? It'd be an integer. Clearly vectors. Complete. That was easy. Thanks. Cool. Adding sprint.
In this module, we'll add sprinting functionality to our player character. We'll add input for this to our cortex settings, and we'll update the character movement speed for when this input is pressed and for when it's released. In our first-person player character, we have our input action jump. We want to make something just like that, but then for sprinting. Let's go back to our first-person settlement, go to settings at the top, and then click cortex settings. Here we'll have to go to engine, and then input, and there we'll see this. All the way at the top, we see bindings, we see action mappings, and access mappings. We want to open action mappings. Here we'll see jump and fire, reset the R. We'll add a new one. Now we're able to name our new action. Call this sprint. Now we're able to associate keys with this action. I will choose for left shift. If you want to add more, you can
Oh
add
boy. Okay. 4 minutes. That'll be done in a little over a minute.
Connect and make sure that when we press it, we update it, and when we release it, we update it again. Let's make sure that we have a variable for max sprint speed. I'm actually going to duplicate FB max walk speed, so select it and then Control W to duplicate it. Call it FB max sprint speed. Compile, we can now give it a value. It also took the value from the max walk speed because we duplicated it. I'm going to set that to 800. Compile.
Why are you...
Let's drag in max walk speed. Get. Connect it to when we release. Let's set the sprint speed. Hold Control to get it. Connect that to when we press it. So now when we press Shift or any other binding center, it will set the max sprint speed as the max walk speed, and when we release it, it will set our default max walk speed as the max walk speed. Compile, save. We can actually play.
Why are you prefixing your variables?
Okay, that's great. It might be a good idea to keep track of the fact if we are sprinting or not. So we want to create a new variable for that, and this is going to be a boolean. I'm going to take that plus variable, and it will create a boolean for us, and we'll call this is sprinting. Compile, save. Default is false because by default we are not sprinting. We don't need to make this editable because we don't need to change this for a level instance, but we can drag this out. Hold Alt while dragging it out so we can set it. So instead of holding Alt, we also drag it out and say set is sprinting. We'll connect these up. So when we press, are we sprinting? Yes. When we let go, are we sprinting? No. We might need this in the future. Let's go ahead and select everything, press C to comment it, and we'll call this sprinting. Reposition that. Okay. Compile, save. Our character can now sprint. In the next module, we will allow it to crouch as well.
Well, this one will take a little bit.
In this module, we will be adding the logic for crouching to our first-person player character.
Oh,
We'll
are
run some
we...
steps from the previous over all the special cases. So we run, we crouch, we start running again, it stops us from crouching, we let go of crouching, we're still going. Crouching again, running again. So this is something important to keep in mind. The more input actions you add, the more complicated your code becomes. The more the same note you call, the more you have to keep in mind all those locations where you call those notes. For example, in this case, we have the maximum walk speed. We're calling that note in a lot of different places, so we need to make sure that they don't interfere with each other. We just added our first timeline to gradually change variables on our player character. In the next module, we will add a health variable.
Widget blueprint introduction. Post-process volumes, that actually could be interesting. Oh, well, we're adding health and debug damage.
In this module, we will set up a health variable for our work in the first-person player character to subtract health, and then when our health reaches 0, we'll for pressing P. I think P is a good key for taking damage. P keyword, and then we see it, health again. Alt take a big chunk of debug. We'll just do this with, there we go, it restarts. Movement variables. Let's call this category well. In the next section, we will have a look at adding info to the player screen and how to set up a post-process volume. In this module, now a lot of this is good. The text is pretty nice. We'll do as you want. So every frame, a button, add custom. Then we have a reference to our probe, what the percentage is like. Let's make that 50. Then we want update health bar. So after creating it, we need to so right here, when I press B, you can see I start taking damage. And when I go below 50, the health bar color will change to red. That was our introduction to widgets.
How would you add new input action? Project settings, input, new action mappings. I guess that's the old way you would do it, but yeah, there's a new way to do that now. You want to gradually change a float from 0 to 1 over 5-second time period. What is the most straightforward node to use? Event tick. You want to check if you're... It's not really event tick because that's every frame. You want to check your health variable value is 0 or lower. Less or equal to? Why don't you need to set up a binding when you're updating a health bar in UMG? When the health variable in the player when the health variable in the player updated, it is automatically updated in the widget? Wait, only need to update the widget when the health variable in the player is updated. We can use an event instead. You want multiple different post-process volumes in your level to tweak saturation. Some volumes overlap. What is the easiest way to make sure the right volume is enabled? Post-process?
In this module, we will have a look at the post-process effects. We will have a look at the post-process volume in our level, and we will add a post-process component to our character. We will use this post-process on our character to be able to change the look of your scene so dramatically. When we go to the world outliner, you can already see that there is a post-process volume over there, and it is already changing some things around. So when you click on it, you're exposed to a lot of different settings, and the most straightforward ones would be under cold grading. You can change the temperature, change it to really warm, change it to really cold. When I reset that, you can change the tint, and you can change a whole lot more settings. In the scene over here, you can see that I put saturation on 1.1, and I did something with the contrast. We will also be working with saturation in our character. Now this is a volume, so I've currently have it set to infinite, unbound. So now even if I'm here, you can still see the effect. But if I turn this off, the effect is also turned off. You can see it's a volume. So when I go into the volume, it's enabled again. It also uses priority. So if you have a different volume with a higher priority, the one with the high priority will apply its effects, and the one with the low priority will be ignored. Just like you have a post-process volume, you can also add a component. Let's go to our first-person character and add a post-process component. Post-process. This is basically the same, but it's unbound and not really a volume. It's a component, so it just applies these settings. Let's compile. With the post-process volume selected, change the priority to 1. This will give it a higher priority than the one that we have in our level. And we want to set the blend weight to 0. So by default, it's not really enabled. Blend weight determines how much it should apply to the scene. So it's basically just a multiplier of the whole volume. So what we want to use it for is to drain the color from our screen as our health goes lower. So we'll put saturation on 0. This will drain all the color from our scene. But then we'll use the blend weight to update how heavy this is being applied to our scene. Compile and save. Let's move up our debug and extend it a little bit and drag this out. So just as we update our health bar, we want to update our post-process volume's blend weight. So we can get a reference to it.
Priority settings. So, okay. Over 5-second time period. Timeline?
Connect these two. So now we're updating the health chunk of damage. And we'll just do this with a, let me just walk into this corner. In here is to clean things up a little bit. we'll put our variables in their category. So we have the movement variables. Let's call this category movement. So I'm going to press bar. So you can make that, we'll call that 100. Health variable, we define ability. And we need to create a rule. Anything on construct, we don't need to do anything before it's constructed. We don't need to do, which is right here, WB health bar. But we aren't done yet. When you create a widget, it just means that it, and we'll call this WB. And we can now call update health bar. And we'll place that in the middle. Move this down a little bit. And we can feed in our new health into the update health bar. Compile and save. And when we press play, we now have a health bar. And when I press B, you can see I start taking damage. And when I go below 50, the health bar color will change to red. That was our introduction to widgets. But feel free but we can drag this out. Hold Alt while dragging it out, so we did, and we'll call this sprinting. Reposition that. In this module for C is call an event print speed camera. So if we go, we will name this timeline T_crouching. Move it up a little bit. And as you can see, there's a lot of different inputs here. There's play, play from start, stop, reverse, reverse from end. Sometimes it's best to call play from start. Sometimes
A door parent?
in this module, we will create our own parent blueprint for a door. This door will have an animation for opening the project, but does not have the capsule collision complicated. How long do we want this animation to be? I think 0.75 seconds should be fine.
Best collision preset if you want the first person character to overlap with the volume. Generate overlap events needs to be enabled on both actors if you want to generate overlap events between the two. Yes, they do. Using blueprints, you can enable input on any actor in your game by calling the enable input node. Any actor in your game. A child blueprint can inherit the functionality of their parent. Yeah. That's kind of the point. How would you update the opening speed of all child door actors? Update the opening of all after having created multiple children of a door parent. Wait. Update the opening speed of all child door actors after having created multiple children of a door parent. Update in the parent. Should change the children automatically if you update the parent. However, I will add that that does not actually always happen. Especially if you have created if you've made a change specifically in a child, it will not necessarily propagate to that child if you make a change in the parent. You can only have one function per blueprint interface. No? That'd be weird. Okay.
In this module, we will serve as a pressure plate. When we, or anything else, stands on top of it, in the next module, we will enable input on a child of the door and set up logic for when an input is pressed. In this module, we will create a new to open and close our door when we are close. Introduction to blueprint interfaces. In this module, we will create a blueprint impulse and sounds, which can be very important to deliver a necessary layer of polish to convey your idea.
Hold on. Let's go to this quiz. Start. What nodes would you use to play a sound and particle when an actor is destroyed? To play a sound and particle. Spawn emitter at actor location and spawn sound at actor location? Wait, spawn sound and emitter. Wait. Okay, I see what they did. Okay, interface functions can have an input and output variable. I'm trying to think. I believe so. How do you implement a blueprint interface into a new blueprint actor? Oh. Uh, let's see here. Trying to remember where that is. Class settings, details panel, locate interfaces category, and add. Next. A sound cue can play a random sound wave. That sounds sort of like a trick question. Complete. We passed. Oh, I wasn't done.
In the next part, we will wrap up the course. We've reached the end of this first course.
And we're now Blueprint Master. Ow. We did it. We did it like, actually it was a lot easier than 6 to 7 hours of video content. Wait. I have a new badge. I've unlocked a bunch of badges. They sent that. All right. So cool. Well, we're done. That's really all there is to it, folks. I don't know what else there might be to do, but that's the show. Wow, that's weird. Why is it? Oh, I think it's just the remote desktop. All right. Well, folks, that's where we're going to call it tonight. We'll be back. Yeah, we'll be back. Okay, I was like, is it Wednesday or Thursday? I don't remember. We will be back tomorrow doing I don't know what yet. So, thanks for stopping by. I hope you have a great rest of your night. We'll see you tomorrow.